in the in the re-attempt, we are means the marks you are taking is best of 2 for each subject, right?
Okay. See, actually, we can discuss in the end of the session. Okay, don't worry about that. We
Actually,
will start this
means
session.
I just want to know whether I can only take one subject, means I can only focus on one subject, and if I get less marks, that is less than 40% in any other, and then will it be considered because
Yeah.
I have already cleared that subject?
Same doubt, sir. Same doubt with me, sir.
Same doubt with me, sir.
It's not. It's not mentioned in the. I mean.
So just means go through the process, means if we have to get 40% and then the marks will be considered.
Overall 40%.
Yeah. Hello.
Yes, sir.
Yeah.
Yeah. Sorry, I got disconnected. Yeah, I was saying. Is it? It's not mentioned in the.
No, sir, it is not mentioned. I have also asked, but they didn't reply.
Okay. They will reply. They think they were some busy in some task. So just okay, and I will discuss with the support team. Okay, I also will discuss with the support team, and I will get back to you. What is the criteria? Okay, no worry about that. The exam is on 30th, right?
13th.
It is on 13th.
Okay. You will be notified. Don't worry about it. Yeah. So you people can mute yourself, and we will discuss first syllabus concept, and whenever you have doubt, you can raise your hands and ask whatever. Okay. Okay. So
Sir, I
can you
have a
mute
Okay,
yourself?
sir.
question in assignment, practice assignment, Simpson's
Yeah.
paradox.
See. This is the revision session. Okay. So first we will go with the
Okay, it's revision
syllabus,
session. Okay, no problem, sir.
syllabus, and after that we will discuss. No.
But sir, why the means why only discussion session for?
Sorry. You are not audible.
No,
So he's saying why only
for
discussion for
stats.
statistics and computational thinking? Why not for maths and English?
Actually, I have no idea
Maths
about
also.
other course.
No, they have gave for math also.
Please
mute, guys, please.
Yeah. Please, you can one second. Let me mute everyone. Yeah. So see, and just let me know if by mistake if I left any topic. Okay. Yeah. We will start with the statistics. If you go for the
Same doubt.
in the yeah week one syllabus. What is statistics? Statistics is nothing but is the art of learning from data. Okay,
Okay,
is the
sir.
art of learning from. Okay, everyone, and what is two branches of the. I mean, how many branches of statistics are there majorly?
There are two branches.
Two, sir.
Branches,
Descriptive and
inferential.
inferential statistics.
Yeah, first one is descriptive, and
Summarization of
second one
data.
is inferential. Okay. So what is
Drawing
descriptive? Descriptive
conclusion
is
from
nothing
data is
but
inferential.
Describes and summarize the data.
Please kindly mute yourself. Okay. Then I will ask, then you can unmute and okay. Yeah. Descriptive is something. It is a part of statistics which is concerned with the description and summarization of the data. Okay. What is the meaning of description and summarization of the data means? See, summarizing data means you are coming, main points of something. For example, I'm saying you have data and I'm saying calculate the mean, median, mod, etc. Okay. That means you are summarizing the data, you are describe the data, and descriptive statistics can be performed on sample as well as on the population data. Is it okay till this point?
Yes, sir.
Yes, sir.
Yeah. Fine. Now,
Okay, sir. Okay, sir.
if you see, next part is inferential statistics. What is inferential? Inferential statistics is something when you concern with the drawing the conclusion about the population on the behalf of the sample data.
Yes.
Okay. Inferential is something drawing conclusion for population on behalf of the sample data. It's okay. And
Yes,
you know very well what is sample. Suppose this is the population. Okay, so sample will be like something this one,
subset of population.
subset of the population. Okay, it's clear. And population is something. Suppose I am saying define the population. Population is what? Population is total collection of the all of the elements in which we are interested. It's okay.
Yes, sir.
Suppose
Yes, sir.
suppose I am interested in a in the yesterday of the marks of class 12 all over the India. Okay, so all the students, okay, or in whole India of class 12 will be the population. It's okay. Hello.
Yes, sir. Yes, sir.
Yes, sir.
You got this point? How? What is population? Population is nothing but it is the collection of all the elements in which we are interested in. Okay. So
Okay, sir.
I want to I want to do a study on the marks of the class 12th of all over the India. Then all the students who are yesterday in the class 12 will be the population.
Hello, sir.
Right? Yeah.
Hello, sir.
Yes.
Today class only for qualifier content focus.
Yes.
Okay, should I leave?
So, and what is the sample? Sample is nothing but it's a subset of the population.
Not week 5 to 8.
No, it's 1 to 4.
Okay, thank you.
Okay. Sample is any subset of the population. Yes. Okay. Suppose I took the data of data of 1,000 students from every state all over the India. So that 1,000 students will be the sample of the our population.
Yes, sir. Total student
Got
of
it?
India.
Yes. Now it's clear.
Yes, sir.
Yes, sir.
Yeah. Descriptive is clear to you.
Yes,
Yes,
sir.
sir.
Yes, sir.
Differential is clear to you.
Yes, sir.
Yes, sir.
Suppose I'm saying. So just see, please. Yeah. Suppose I'm saying I have a data. I have suppose I'm saying I have data of marks of 10 students. Okay. Marks is like 72, 70, 69, 58, 92. It will be around 1, 2, 3, 4, 5, 6 up to suppose 10 students. So he got 68. Okay. And I'm saying calculate the mean of this marks. Okay. So what will be this study? Descriptive.
Yes, sir.
Yes, sir.
Yes,
Suppose for assume mean marks is came out to be around 62, for example. Suppose, and after that I'm saying the average marks of whole class is 62. Then what what kind of yesterday is this?
Inferentially shared rates.
Inferential.
It will be inferential because on the behalf of
Yes.
this sample data, you are making conclusion for the whole class, for the whole population. Okay.
Yes, sir.
Now I think there's is there any confusion regarding descriptive inferential sample population?
Sir, can I ask something?
Yeah, please go ahead.
So whenever we take a sample of a data, can we assume that it should be inferential?
No. If you making conclusion for that sample data for the whole population.
Oh.
Okay.
Okay.
For example, suppose there is a class of suppose 40 students. Okay.
Okay.
And I took the sample of marks of 10 students. Okay.
Mhm.
So this is your population. This is your sample.
All right.
Right.
Yeah.
Then suppose I'm saying I calculate the average marks. Okay.
Mhm.
And average marks is suppose 68. Then I stop here. I said, yeah, average marks of 10 students is 68. Then what will be what kind of study will be this? Please listen to me. I said average. I said the mean marks of the 10 students is 68. Then what will be this study?
That will be descriptive, right?
Inference, yeah.
That will be
No,
descriptive because you are not.
I
okay,
just
got it.
describe the data. I just say mean marks of the 10 students is 68. I just describe this data, data of 10 marks.
Okay.
It's clear?
Yeah.
And suppose I say the average marks of whole class is 68. Then it will be inferential.
Okay, got it.
Got it?
Yes, sir.
And see, descriptive statistics can be performed on the sample as well as on the population, because I can also calculate the average of these 40 students. Right? I can calculate the median of these 40 students.
Okay, and that would be descriptive, right?
Yeah. Descriptive statistics can be performed on sample as well as on the population.
Okay.
But inferential is something in which you are making conclusion for the population on the behalf of the sample data.
Okay, got it, sir.
Got it?
Yeah.
It's clear to everyone?
Okay. Yes, sir.
Yeah. Okay. So we can move ahead. So next topic is data. Okay. Any one of you can tell me what is meaning of the data?
Facts, numbers.
Facts, numbers.
Just fact and figure.
Yeah, these are something. These are the facts.
Facts and figures.
I say kindly mute yourself. Okay. Don't make yours. Yeah. This is something. Facts are figures which are collected. Okay. Okay. Analyzed and summarized for presentation and interpretation. Okay. So data, suppose suppose comments on any YouTube, that is also data. Okay. Image files is also data. Suppose I collected any marks of 10 student, like 10, 20, 30, 40, like that. This is also data. Okay. See, now data has two types, two basic types. First one is structured data, and second one is unstructured. It's okay. See, structured data is something which is in already in a predefined manner. Okay. And structured data is something which is clearly defined and searchable type of data. And unstructured data is something which are in a qualitative form, and it has variety of formats. You are not you cannot infer in any information in a easy way, right?
Yes, sir.
Yeah, see, suppose I'm saying uh yeah, suppose this is roll number.
Sir, what does it mean? Like any infer in
One second.
structured manner?
That's I'm explaining students name, and suppose there is his mobile number. Okay, suppose roll number is 22, student name is Ramesh, and mobile number is 7927 and something, and roll number is 23, and see, suppose I'm saying Rohit, and mobile number is 9823 and so on. Suppose I'm saying 33 roll number is, and suppose saying I'm Suman, and her mobile number is 8828 and so on. Okay, and suppose I give this data to you, okay, in a tabular form. Okay, so this is some data, a data which you can call as a structured data. Means suppose I asked tell me the mobile number of Rohit. Okay, then you can easily search the mobile number of the Rohit. It's already in a predefined and structured and in an organized manner, right? Suppose I ask you tell me the roll number of
Excuse me,
Suman.
sir.
Yeah,
Sir, can I say structured data is always in tabular form?
yeah, you can say.
Yes.
But sometime in structured data in tabular form, there are suppose there is suggestions which is not generally in structured form. Okay, see, you can interpret like that when you are easily easily search the information, then it will be the structured data. It's, see, just a simple thing, it's always in a predefined manner, it's in already in organized manner, it's in a standardized format. Okay, and unstructured data is not usually in a predefined manner, in a organized manner. Okay, is it clear? Structured.
Yes, sir.
Yes,
Okay,
sir.
suppose suppose I'm saying Ramesh, uh, okay, Ramesh is a student and his roll number is 22, and his mobile number is 7827 something, and Suman is a student and her roll number is 20, suppose it's 23, and her mobile number is whatever it is 9828 so on, and suppose I'm saying Rohit is a student. Okay, so Rohit is a student and his roll number is this and his mobile number is this, and suppose this data is given to me. Okay, and then I said suppose just tell me the roll number of Suman, then it's you cannot find the information about the roll number of Suman in a easy way. You have to read from start from this and go second line and go with the third line, then you will get the roll number of Suman is 23. So this is something on this type of data called unstructured data, right?
Yes, sir.
Now you got it.
Yes, sir.
Difference between the structured and unstructured.
Yes, sir.
Yeah.
Everyone,
sir.
is everyone okay
Yes,
till
sir.
this point?
Yes,
Okay. Okay. Now we will study the variables and cases. Okay. See, you know what is cases? Cases is something, a unit from which data are collected, and a variable is something that varies. Okay. So suppose, yeah, let me go with an example. Suppose there is a roll number, name, and suppose marks. Roll number is about 23, name is Rohit, marks के 57, 33, Suman 78, and 43, Rohan 92, 52, Rahul 58. Okay. Suppose this data is given. Okay. So can you tell me what is the variable and cases here?
Roll number
is
and
variable,
marks are
name
variables
and
and name
marks
is
are variable.
cases.
Sir,
See.
roll number, name, and marks are variable, and
Yeah. Yeah.
Each name is case.
roll number is a unique.
Yes.
That's why it's a cases.
Roll
23,
number,
33,
name, and
40.
marks are
Name is
variable.
also cases.
Why variable? See, listen to. Why variable? Because it varies. Okay. Name is also vary.
Each name is case.
Yes.
And what is, see, generally, no, columns represents the variable. So this column represent the roll number variable, this column represent the name variable, and this column represent the marks variable. It's okay. And what cases? Cases is something which are unique. Okay. Suppose here, suppose I'm saying, tell me about Suman. Okay. Is Suman is a case or not?
Yes.
Yes, sir. Yes.
Suman is case because Suman is here unique, and
Yeah.
cases,
Must have its own
row
row.
represents cases. Okay. Row, normally row represents the cases. See, suppose I'm saying here, suppose another roll number is here. Suppose there is roll number 25, and another student is against Suman. Okay, and his marks is 48.
Sir,
Then,
roll number is also case.
yeah, listen to me. Suppose I'm again saying, is Suman will be case now. Now for this new data, Suman will be case or not?
No, sir.
No, that's not unique.
No. Suman will not be case because Suman is not unique. Here Suman is repeated. But if you see the roll number is unique. So suppose I'm saying 25, then 25 is unique. Suppose I'm asking about this Suman, then you don't know which Suman I'm asking about. Means this Suman or this Suman. But cases should be the unique.
So
Right?
can I ask something?
Yeah, please go ahead.
So in this sample table, the marks are also unique for each student. Does that mean mark can also be
Marks.
a case?
This is just data. Suppose Suman is also so suppose, for example, Rohan marks is 48. Then it will not be unique.
Okay.
See,
okay.
Yeah, cases should be unique. It can be anything.
So if no one has the same mark, does that mean the value of mark can also be a case?
But it will depend on the data actually.
Oh, okay.
But
okay, what is data? Suppose I'm interested in marks and his address, and then. So marks can be unique, address can be same, and university can be same type of. Actually, it depends on the data, but you must care about that. Cases should be the unique, and row represent the cases.
Sorry to interrupt you, sir.
Yeah.
Sir, in the last column, 25 so one is written. If we excluded that and see whole table, then roll number can also become a case.
Yeah, it can become. Suppose I'm asking about the 43, then 43 is a case.
Okay.
Okay.
Okay, sir.
Just remember, cases should be the unit, and row represents the cases.
So there are roll number and names also be a case.
I said it depends on the data. Okay.
Okay, so it depends
Generally,
on how
roll
the
number will be, roll number is unique if you see in any college or university.
Okay, so sir, does that mean it would depend on how the data is being used
Yeah.
rather than how it looks?
Yeah.
Okay.
Okay. It's depends on what is data. Yeah. Please go ahead.
So if we add a blood group here, then can I call each blood group as
But
case?
blood group can be same. Suppose Rohit has B positive and Suman has B positive, then it will not be case.
Okay, sir.
Okay, actually, that's why I said it's depend on the data. What is the data? But just remember the cases should be the unique. Okay.
Okay, sir.
Okay. So till this point, any doubt, or we can move ahead?
Yes, sir.
Yeah. So data has two types: categorical data and numerical data.
Excuse me, sir.
Yeah.
I have a doubt in blood group.
Yeah. Yes.
Yes, sir. Sir, the blood group now it is not considered as a variable, right?
No, you can consider as a variable.
It doesn't vary, sir. It has two of them has the same blood group.
Variable can see. Suppose I inserted a column of blood group and B positive, A positive, and A negative and B negative. Okay. Then this column, this blood group column, if you see, the things are vary. B positive, A negative, B negative. This blood group, this particular thing is, this particular column is a variable.
Okay, sir.
But this B positive is not a case.
Sir, B negative can be a case.
No. Case means, suppose I'm considering this. Suppose I'm considering this column, then these things should be the unique.
Sir, B negative, why is not a case? It should be a case.
So in this whole table, okay,
yes,
suppose you are talking about B negative, okay. Suppose I'm asking, just tell me B positive, then will it be case?
No, sir, that will be not a case. Yes, sir.
So, but it can possible, like suppose this is just a small data, and suppose you have large data, then it can possible there will be B negative type of things. More
sir,
and
but
more.
Sir, but in this data, B negative is not repeated.
And one more thing you have to remember, cases should be the unique. Means in this column, all the things should be unique.
It means that, sir, in the name column, someone is repeated 2 times, so
Yes.
that row or column we can't consider as a cases done now.
Yes. This will
Okay.
not a good, this will not be a best practice. Actually.
Yes, sir. Yes,
Okay.
sir. But it is a case, no, sir. Not
But
best practice,
suppose,
but it is a case.
Suppose blood group is unique. For example, A positive, A negative, and B negative. Okay. And
Yes,
roll marks is repeated and the name is repeated. Suppose the roll number is not given. Let it be this column. Okay. Then you can consider it's as unique thing.
Yes, sir.
Okay, but
Yeah,
I
that's
said
okay.
it generally depends on what type of data in front of you.
Yes, sir. Yes, sir.
Okay.
On another example, because it is becoming very confusing.
Yeah,
yes, sir.
Yeah.
हेलो सर
Yeah.
जो आपने दिया था रोल नंबर का, सिर्फ वही रोल नंबर ही केस हो सकता है ना, इधर पहले वाले जो आपने डेटा प्रोवाइड किया था ना, वही तो
Yes,
सिर्फ रोल नंबर ही केस होगा और नेम नहीं होगा, क्योंकि वो एक
yeah,
वो
it's
रिपीट किया था
repeated.
ना.
Yes. See, I think there is let me cases
Sir,
or
if data are repeated, can we call it as a case?
sorry.
No, if the data are repeated, can we call it as a variable?
Yeah, variable is something which represent the column. Means column represents the variable. There are questions I don't remember in which activity is there regarding cases or variable.
Yes, a gas cylinder and bike names are.
In which activity that was?
We am also not remember, sir.
Graded assignment, sir.
Yeah, suppose
Yes,
this
sir,
one. For example, suppose this one, okay? This temperature, okay? So here, if you see 9, 9:30, 10, 10:30, all things are unique. No one is repeated. So this 10:30, 11, 11:30 will be the case here, okay? And in temperature, if you see 31, 31 is repeated, 35 is repeated, 36 is repeated. So it will not be a best practice saying that 36 degrees Celsius is a case. Because in this column, if you see, observations are repeated.
अगर सर एक ही ऑब्जर्वेशन जैसे 31 रिपीट हो गए तो बाकी ऑब्जर्वेशन भी अपन केसेस ऐसे
I
कंसीडर नहीं
said
कर
it
सकते.
will not become a best practice. Okay. You must remember about the unique. Suppose I am saying 10:30. 10:30 is unique. Okay. It's a case. And on the behalf of 10:30 AM, you have temperature and you have a humidity. Okay. And I'm saying 31 degrees Celsius. So you don't know which 31 I'm talking about, this 10 AM, this 10:30 AM, or this 2:30 PM. So cases should be the unique.
Sir, right? In graded assignment 1, we can find the best example for this.
Okay, just tell me.
Graded assignment 1, 5th question, sir.
Is this yeah, grade assignment 1, okay?
Yes, sir. Question number 5.
Question number 5. Yeah. See here. See brand. Suppose I'm saying Audi. Audi is not a case because Audi is repeated. But if I'm saying model name, so A73.0 TFSI is a case because it's a unique model name, is unique. So this type, see, actually I said earlier, it depends on the what type of the data is in front of you. Okay, so here model name is a unique thing for brand, fuel type, or number of cylinders, whatever. Suppose I'm asking about the I10 sports. So I10 sport is a case because it's a unique here. Okay.
Sir, so will mileage will also be unique in that table?
Yeah.
Will that be a case?
Yes.
Okay, but but mileage can be I think mileage can be repeated. Okay?
Yes, sir, it will be repeated.
It will be repeated.
Mileage can be repeat, na?
Yeah,
Oh,
mileage
okay.
can be repeated, but model name will not be repeated.
Okay.
So
So
mileage
we
is not a
would,
case.
because we can move because we have to a lot of syllabus actually. Yeah, data which have categorical and numerical. Categorical is something which is qualitative in nature. Okay, and numerical is something which is quantitative. Right? And numerical is something which has again two types, means discrete and continuous. You all of you know very well, right?
Yes, sir.
Sir,
So yeah.
Sir, in activity question 1.2, third question I have a doubt, sir.
See, let's finish first syllabus of week 1, and after that we will discuss doubt of week 1 and week 2, and then forward. because we have to cover all the topics of the up to week 4.
Yes, we
Okay.
do have a computational thinking revision session in 6 as well.
Actually, I'm not sure about the computational thinking CT course. Yeah, see, categorical data is something.
Sir, you have to finish it within 2 hours, all the
Yes,
4
sir.
weeks,
Yes,
because
sir. Because
don't
we
waste
do
your
have on
time on
6
any
o'clock.
other
Yes,
thing.
yes.
Don't
See,
answer
see,
any
see.
question.
CT classes, sir.
See,
Yeah.
CT
sir.
classes is today.
Yeah, we have that.
Yes, sir.
We
On
have,
which
sir.
time? Which time?
Yes, sir. 6.
6 to 8.
6 to 8.
Is it?
Yes, sir.
Yes,
6 to
sir.
8.
Okay, okay, then okay. See, in categorical data, you have to identify about the categories. Suppose I'm saying you have category of male and female. Then this type of data called the categorical data. Okay, and numerical data is something which are represented in the numeric form, which are in the quantitative form. Suppose I'm saying marks. So marks is in quantity, like it can be 10, 20, 30, 40, like that. Okay. See, now, and now, you know what is a cross-sectional data and time series data?
Yes, sir.
So cross-sectional data is something which are collected at
Over a
Same
period.
time.
no, at the same
At
time,
the same time.
and time series data is over time.
Recorded time.
Okay. For example, I'm saying suppose I recorded the temperature in Delhi, Mumbai, and Chennai at 10 a.m. Okay. Then suppose whatever temperature x degree Celsius, y degree Celsius, and z degree Celsius. Okay. And it can possible I recorded the temperature in Delhi at 10 a.m., 11 a.m. and 12. So it can be x degree Celsius, y degree Celsius, and z degree Celsius. So here, if you see data means temperature is recorded over time, means time vary at the different time, but place is the same. But in cross-sectional data, place are vary, means place are different, but time is the same. Means at 10 a.m. I recorded the data at Delhi, Mumbai, and Chennai. It's clear?
Sir, I have a question. Can I
Yeah.
ask? Sir, I want to know if the bill of a customer who solved on a particular day is a cross-sectional or time series data.
Can you repeat?
The bill of a customer on a specific day who purchased some of the items from the shop. It is one of the questions actually. And I think it will be not cross-sectional.
That should be cross-sectional. Why?
Cross-sectional only, no?
No, it's depends on sometimes time varies per hour, per minute also.
Okay.
It can happen. Okay.
But here you are saying the places are different, right?
No, I'm saying,
he is shopping from the same shop.
No. See. I'm saying places are different means here time is same. At the 10 a.m. Someone recorded the temperature of Delhi and in the Mumbai and in the Chennai. Okay. Here time is same, but here time is very
different.
Okay.
I understood.
It's 1 second in the
Sir,
I
10th
think this
question.
will clear if in this one 10th. No, it's
No, sir, included assignment only.
Hello, sir.
Okay.
The temperature question what you have opened, right? That is
Hello,
also time
sir.
series.
Yeah.
The
Sir,
temperature
marks
question,
is discrete or continuous?
It depends. Generally, it's
Generally, it is
discrete.
discrete.
Yeah, see, in this example, in order to forecast tomorrow temperature in Mumbai, the India Meteorological Department collects the temperature, humidity, and rainfall of the Mumbai for all days from the past 3 months. What kind of data this? If you focus on past 3 months, yani
Time
you are
series.
collecting the
Time
data.
series.
It is a time
It will be,
series data.
yeah. Now it's clear because time is vary.
My
Okay.
question is not this one. Actually, there was a question of bills. Who means someone
Okay.
swapped the bills. I think it is in the second one. I have
Second
to
one.
check.
Sir, I think at this
Oh,
point
just
we
you
have
can.
to leave
Yeah.
the
So you got the see now here
Sir,
during the
kindly
Great
continue.
Depression.
Continue. I understand.
Yeah. Several countries across the world experience rate of unemployment. The unemployment rate between the years this and this was recorded. So what will be the this data?
The time series.
Time
Yeah,
series.
the time series. Okay. If the time is same, okay, period is same, then it will be the cross-sectional data. Okay. It's clear to everyone?
Yes, sir. Yes, sir.
Yes, sir.
Okay. Nice. Now we can move for the scale of measurement.
Yes.
Yes, sir.
See, there are four
Yes, sir.
scale of measurement. Nominal. Second one is ordinal. Then
interval,
and fourth one is
interval and ratio.
scale.
you know these two scale of measurement is used for the categorical data,
Categorical data.
and these two is used for the
Numerical data.
Numerical data.
Okay, nice. See, nominal data is something, okay, which are normally in short you can say name without any order. Okay, this is something name categories without employing any order. Means any categorical data where order is not matter, then nominal scale will be used. Suppose I'm saying female male, then this will be nominal data, nominal scale of measurement. Okay, suppose I'm saying a category of vegetables. Okay,
Yes, sir.
suppose you have vegetables like onion, potato type of things. So for this vegetables you can use nominal.
Yes, sir.
Because you cannot say like you cannot order like potato is more greater than tomato or type of things.
Yes, yes. Move on.
Okay. Then when order is not implying, then nominal will be used.
Sir, mobile number, model number, and those things will also come under nominal
Mobile
data.
number is also nominal data.
Yeah, okay.
Yes.
Suppose I'm saying Aadhaar
Yes,
card number.
It's a
It's
nominal.
also nominal. You cannot say your Aadhaar card is exact same as my Aadhaar card number, or my Aadhaar card number is more important than your Aadhaar card. Okay, you
So
cannot
serial
imply
number.
any order, and you cannot do just you can do a category.
So what about serial number?
See, serial number is not at a variable at all.
Yes, sir.
Sir, jersey
It's
number is
also a nominal.
also a nominal data. No?
Yeah, jersey number is also nominal data. Suppose I'm saying blood group A positive, B positive kind of thing. Okay, it's so nominal data. Okay, now is it okay to everyone?
Yes, sir.
Yeah.
Yes.
Now ordinal data. Okay, ordinal data is something name categories.
Sir, for serial number, why is it not a variable? Because it is varying, right? What is the logic
Yeah,
behind
but
it not being a variable?
it varies. You are right, but it's not a variable at all, because serial number is something. Suppose I did not insert the column of serial number, but
Because
even
it is
that
internally generated and not from external observation.
Yes, type of things you can say.
Yeah.
See, ordinal is something name category that can be ordered. Suppose I'm saying t-shirt sizes. Okay, small, medium, and large. So this type of data you can order. Hello.
Yes, sir.
So this type of data will be the ordinal data. Suppose I'm saying you gave a rating on okay, any type of things. You read you used a laptop of HP and you give the rating. Yeah, this is the good and excellent or poor in performance. So you can order this. So this type of categories, categorical data, you can use ordinal scale of measurement.
And ranking also ordinal, sir.
Yeah, ranking or ordering is
सर अगर नंबर में दिया जाए तो वो क्या होगा?
सॉरी,
रेटिंग अगर नंबर पे दिया जाएगा, अगर 1 to 5 आप इन बीच में कुछ ऐसा दे दो, मतलब हम अगर कुछ खरीदे और वहाँ हम रेटिंग उसमें 5 दे, 5 के अंदर 5
और but say suppose you are giving rating 1 2 3 4 and 5, okay, it will be interval.
Yes, sir, that would be interval, no? Because
but yeah, but listen to me. But I'm saying suppose I'm saying I give the one, I see, suppose they're rating like bad, good, average, very good, and excellent. Okay, then I suppose I have coded bad as 1, good as 2, average as 3, very good as 4, excellent as 5. Then it will be the ordinal. Listen to me. I said if I coded bad as 1, good as 2, average as 3, very good as 4, excellent as 5, then it will be ordinal, because you can easily say that 1 is for bad and good, 2 is for good, and 3 is for average, and very good, 4 is for very good, and 5 is for excellent. Right?
Yeah, sir.
But sir, can you repeat one full time?
Suppose I'm saying, see, tell me, I can code like female as 1, male as 0, or female as 1, male as 2.
Yes,
type
sir.
of thing. Then even though it will be the ordinal, nominal, because it represents in the number, but I have coded. I know 1 is for female, 0 is for male, 1 is for female, 2 is for male.
Okay.
Similarly, here suppose I coded bad as 1, good as 2, average as 3, very good as 4, excellent as 5. Then it will be the ordinal, because you know 1 means bad, 2 means good, 3 means average, 4 means very good, 5 means excellent. But in general, you have chance like you have to just give rating 1 2 3 4 5, then it will be interval, because it's assumed that difference between these two is 1. And you know what
sir,
is
I have a question. Can we think 1 2 3 4 5 as labels?
If you mention that label, or you are coding that level, then that will be the category. Otherwise it will be the interval, because it represents in the
okay, got it, sir.
Numerical form. Got it,
sir? But why name is a categorical variable then?
Why name is, where name is categorical?
Name is a nominal. One of the question it was,
no, name is a nominal.
It is a nominal variable. I think there was some error which was not fixed.
See. What was your
question?
You
say name are labels, so we can take it as categorical variable.
Yeah, name is a categorical variable, because see, name is something. Suppose I'm saying Rohan, Mohit, and XYZ, whatever. Okay, these are not a number. It's a categorical. It's a category, name category. So that's why it will be a categorical variable, because it's in a qualitative format.
Yes, sir.
Okay, sir, got it.
Got it?
We can't perform any mathematical operation.
So we will move for the interval scale.
Sir.
Yeah.
Hello.
Yeah.
మళ్ళీ చేస్తే మళ్ళీ కట్ అవుతాయి డబ్బులు. ఇప్పుడు ఇది
चाहिए ना. Question number 3 देखिए.
Sorry.
1.4 में.
So can you mute centrally, sir?
एक बार.
1.4.
सर टाइम नहीं है 6 बजे तक करना है सर कर
one second.
We don't have time, sir. We need to complete it in 2
Which
hours.
which question?
Question number 3.
नहीं तो ये सर count.
Yeah, this one.
हाँ sir.
Okay.
हाँ.
What
तो
is your doubt?
इधर क्यों इंटरवल
Sorry.
इधर क्यों इंटरवल स्केल नहीं होगा आंसर?
See, let me finish the
less than
concept of
zero भी
interval
है ना?
scale. Okay. One
Less than
second.
30
Let
है
me
तो उसमें
finish
zero भी
once,
include होगा.
one by one. Let me finish the interval scale. After that, I will clarify that thing. Okay. What is interval? Interval scale and ratio scale is used for the numerical data. Okay. And in interval scale is something in which your numerical values that can be added or subtracted, and one is special property is there is no absolute zero. Okay, no absolute zero means here is suppose I'm saying 0 degree Celsius. Okay, suppose I'm saying 0 degree Celsius, then no absolute zero means there is you can't say like there is a absence of temperature.
Yes.
0 degree Celsius means there is some temperature. Okay, that's why here absolute zero property is vanishes. Okay.
Yes.
And interval scale, difference should be the same for each category.
Yes, sir.
Interval should be the same. Okay.
Yes,
Till this point, it's okay to everyone.
Yes, sir.
Okay. Now let's
Yes,
move
sir,
forward
yes.
with this question. If you see, there is less than 30. Here,
Zero.
difference for 30 to 45 is 15, 45 to 60 is 15, but you don't know how much less than. It can be 0 to 30, it can be 14 to 30, it can be 15 to 30. So it's a category. Category 1 is less than 30, category 2 is 30 to 45, category 3 is 45 to 60, and category 4 is more than 60. Okay. And for example, suppose here it is mentioned like 15 to 30, then 30 to 45, 45 to 60, 60 to 75, 85, no, 75, then it will be the
interval scale.
Interval scale, because difference between each interval is same.
Same, yes, sir.
It's clear?
Yes, sir, yes, sir.
Okay.
Sir, if the interval is same and zero is included, then also it will be ratio, right?
Yeah. In ratio scale, all the property of interval is fulfilled.
Fulfilled.
Means addition, subtraction, multiplication, division, and absolute zero. Suppose I'm saying you got the 0 marks. That means absolute zero property is
You got no
satisfied
marks.
here.
Yes.
You get 0 marks means
No marks.
you get no marks.
Yes, sir.
Yes, sir.
And one important
Yes, sir.
thing you can remember, if anything can go in negative,
That will
it
be
can
interval.
be interval.
Yes.
Yes, sir.
Because in
That is
ratio,
minus marking in marks.
yes, minus marking. Suppose I'm saying
Or
minus 2
temperature
marks.
in temperature
Suppose
in
minus 2
Kelvin.
marks. That means here absolute zero properties vanish. You get some marks.
Yes, sir. Yes, sir.
Okay. And in ratio, absolute zero property is satisfied. Suppose I'm saying 0 kilogram sugar. That means there is absence of sugar.
Yes, sir.
No sugar, yes.
Now it's clear?
Yes, sir. Got it.
Yes.
Till this point, any doubt? Anyone?
Sir, if we have the
0
rating,
Kelvin.
Sir, please complete the topic fast because we just have
Yeah.
an hour.
Yeah. We can.
Sir.
Yeah.
Directly go to week 3, sir.
No. Let me finish the week 2 also. Okay. Till this point, it's okay to everyone, right?
Yes, sir.
Yes, sir.
Week 2. In week 2, you know what is frequency distribution, relative frequency?
Yes, sir.
Yes, sir.
Yes, sir.
Suppose
Yes, sir.
any data is
Yes,
there, and suppose data is like
Number
that.
of
A,
observation by total
B,
number
B,
of observation is
C, D.
relative frequency.
Okay. See. This suppose this is there.
Mhm.
So you can like write this one 2211. Okay,
Hmm.
these are the frequency. Frequency is nothing but the count of that thing. Okay,
Yeah.
and suppose I'm saying find the relative frequency of this for A. What is the relative frequency? Just calculate the total, means 2 to 4
Frequency
to
by
6.
total frequency.
So it will be 2 by 6, 2 by 6, 1 by 6, 7, 1 by 6. If you add these whole things, so total relative frequency will be 1.
1. Yes, sir.
Okay?
Yes, sir.
Yes, sir.
Till this point, it's okay to everyone?
Yes,
See,
sir.
Yes,
this
sir.
can be done for categorical data as well as for the numerical data.
Okay, sir.
Okay? Yeah. So yeah, next things is charts. You know, charts are there: pie chart, bar chart, and
Pareto chart.
Pareto chart.
Okay. See, pie chart is something when you have to compare as a part of whole. Means suppose I'm interested in the comparison of proportion of categorical variables.
Sir, the slice of the pie is taken as relative frequency times 360, na?
Yeah.
Okay.
Suppose. Okay. Suppose no. 1 second. Let me think about an example. Okay. See, pie chart is something this one.
Yes.
Okay. And this, suppose this is X%, this is Y%, this is a Z%, and this is a W%. So this is something, and this is the pie charts you have to use when you are interested in a percentage of a whole. Means this is something. Suppose this is 100%. Okay. Okay.
Parts
And
of a whole.
out of these 100%, you have a slice for X%, slice for Y%, and you know how much percentage is for W, how much percentage is for Z. Okay.
Okay.
Suppose see, suppose I'm interested in breakdown of sales for each items for any, suppose of a business. Okay. Then your total sales will be whole pie.
Yes.
Right.
Yes,
and but the slices will tell you how much each product contributes. Suppose each product like pen, register, and any more thing. Suppose pencil. Okay. So total sales will be this whole pie, and you are interested in how much each product contributes. So that will be the slices. Okay. Suppose this one. Suppose your pen is contributing 50%, and your register is contributing around 20%, and pencil is contributing around 30%.
30%.
So here you are interested in whole, out of whole, how much product contributes. Then in that situation, pie charts is used.
Yes.
Yes, sir.
Are you getting this one?
Yes, sir.
Yes, sir.
Okay. And
Sir,
now
but
we
the
will
election
move.
results, the election results are shown in pie chart, right? But if we say there is an election
See,
of
whatever is there, means any type of data is there. If you are interested in comparison, if you are interested in percentage of a whole, then you will use the pie charts.
Sir, we can say comparison.
Yeah, you can say comparison. Suppose I'm saying I'm interested in the count of something.
Then it will be bar chart, sir.
Then it will be bar chart will be the use. Bar chart will be the best practices. Okay.
Okay.
Suppose in a college there are 100 students. Okay. For example, and I want to know.
मम्मी बंद है नंबर मेरो.
Yeah, Prince. Yeah.
बंद हो तो बंद.
Yeah.
Sir, centrally just block this. It just
and see, and there is a class of 100 students. I am interested in knowing that what is the regional distribution, means how much percentage of the students are come from the North India and Southern India, East India and West India. Okay, suppose these are this one, and suppose I got, yeah, X% of students are coming from North India, Y% students are coming from the Southern India, and Z% is coming from the Eastern India, and suppose W% is coming from the Western India. So here you are interested in parts of a whole, then you will use the pie chart. Okay, and for example, I'm interested the count of the students. How means how many students, I mean exactly count. Suppose this one, this is North India, South India, Eastern India, and Western India. Okay, suppose there is a 20, 30, 50 and 80. Okay, like that. Then bar chart will be the best practice to use. You got it?
Yes,
Got
sir.
it, sir.
Here you are interested in the numbers.
Frequency, count.
In the numbers, you are interested in the
Numbers.
count. And one more important thing, if data is ordinal, then order must be preserved.
Then we use Pareto chart.
Then Pareto chart is the
No, no,
optimal.
No.
no.
That is it.
One second. Let me create a new Jamboard. One second. See, Pareto chart is something when you have sorted the frequency in increasing order. Okay, suppose I have data, okay, of region A, and there are 30 students. For region B there are 20 students. For region C there are 45 students. For region D there are 50 students, and I sorted in increasing order, means B as a 20, then A as a 30, and then C as a 45, and D as a 50. Then it will be the Pareto chart.
Yes, sir.
Yes, sir.
And you can plot it as either in increasing order or decreasing order.
Yes, sir.
Okay. But suppose I'm saying you have sizes of t-shirts. Small size t-shirts, you have 30 small size t-shirts, and 20 medium size t-shirts, and large, uh, suppose 35. Then bar chart will be the best practice, and your order should be preserved, means first it should be small, then medium, then large. Okay, it is the
So for
30.
ordinal data, bar chart is the best one.
Yeah, this is the, suppose this is the 35. Here you see on the x-axis order is preserved. I don't bother about the count. I have to preserve the order. It's clear to everyone?
Yes, sir.
Yes, sir.
Got it?
Yes, sir.
So you got the bar chart and pie chart and
Pareto chart.
Okay, now we will
Sir,
move for the yeah.
Sir, can you quickly summarize the errors in charts?
Yeah. Now
That is
at
the
that
most
point,
important thing.
yes. Suppose I gave
Noted
you
graph.
chart like this. Suppose for example,
Very principal, sir.
small, medium, and large, and there I started 5, 10, 15, and 20. Okay. So is there any error?
Yes, sir. It starts from 5, not
Yeah.
from 0,
sir.
missing baseline.
There is
Zero.
There
absence
should be a
of
single baseline, sir.
baseline.
Baseline.
And just tell me one another example. Okay, suppose I plotted this one. Okay, these things and these things. Okay, what is suppose is any product A and this is any product B, and here this axis is represent these sales. Okay, for example, and suppose this is the one second, this is the 420, 430, 440, and suppose this is
Zero
the
is missing.
490.
This line is missing, sir.
Misleading, sir.
0 is missing, sir.
See,
This
here
baseline is
zero.
missing.
Yeah. See, baseline is not see missing of baseline. And if you see the on the bar charts, it's it
Width
will
of bar.
see,
Width is also different. The
yeah,
area
see,
principal, sir.
yeah,
Principle of
listen,
area.
listen to me. It's feel
Principle of
like
area.
this is the 2 times of this one,
Yes.
but originally it is not. Okay, so this type of charts is also called the misleading graph.
Okay, so what is the main name for this type of chart? Misleading charts.
Yeah, you can say misleading graph.
Principle of area.
Yeah, area principle is not
सर
verified
फिर
also.
से बता दो तो समझ नहीं आया.
See, in this one, baseline is missing. Okay.
Yes, sir.
You can say, see, if baseline is missing, then you can directly say it's an
Truncated graph.
truncated. No, not truncated. You can say it's an missing baseline. It's a misleading graph.
So what is the truncated graph?
Here you are misled by like this bar is seems twice 2 times of this one, but originally it is not. Okay, now move for the manipulated y-axis. Okay, suppose I go with this one, and suppose here I start 0 and 5 and suddenly I jump to 15.
Discontinuous.
Okay, and here I mentioned that the for
no misleading.
Okay, so this type of graph will not be misleading.
Misleading graph, sir.
Because here I mentioned that I have truncated. I have manipulated. Sorry, not truncated. I have manipulated.
Okay, sir.
Okay, one thing can be happen, and another thing can be happen like it start from the baseline and 5 suddenly jump on the 25 and then 35, then 45, then 55.
Misleading.
Then it's a misleading. Manipulated y-axis. Here y-axis is manipulated. You got it?
Sir, can you open practice assignment 2.1?
Okay, let me do it fast because we have less time actually.
Right, sir, but
2.1, okay?
Yes, sir. Just one point I just wanted to know.
Yeah.
So what is this? The point number? It is practice assignment 2.1.
This one, this graph?
No, sir. Sir, it's on misleading pie chart. The topic is on misleading only.
Actually, when you refresh, you will get a different question each and every time.
Okay, sir. So in this, it is showing that there is a legend missing, something like this. I'll just share the question one second.
This one?
There is no legend containing the name and share of each group. What does this mean? This can also be the problem with the pie chart, right?
Yeah.
There is no slice has an offset from the center.
Suppose,
the chart.
Yeah, this can be see, I will come on the pie chart. Let me finish this one first, okay?
Okay, sir. Okay.
This type of misleading graph is called manipulated y-axis. You know why manipulated? I go initially 0 to 5, suddenly jump 5 to 25. Here y-axis is manipulated.
Misleading नहीं होगा?
Yeah, it can be misleading. I gave the name manipulated y-axis.
Okay.
It's clear?
So we have to introduce a break in between.
Yeah, if I introduce here break like that, then it will not be a misleading graph.
Manipulated y-axis.
Missing y हो जाएगा ना sir?
Sorry?
Sir, if it is there is a break in y-axis, then it will be missing y-axis.
No, not missing y-axis. Okay. Okay, so this point is clear to everyone. Okay.
Yes, sir.
Now we will move for the pie chart. Pie chart. See, error in pie chart is something. Suppose I rounded off the
errors.
Okay. Something this one. And for example, I add this one and got the 101.2%.
Round of error.
Then this type of error called the round of error in pie chart. And someone has also about the labeling. Suppose I draw the pie chart, okay, and I did not label any. Suppose here is red suppose one second. This one, this one, this green, and this red. Okay. Suppose I did not label what this red region is represented, what this yellow region is represented, blue region is represents, and green region is represents. Then you did not get you will not get any information like which slice
This
is
is
represent
also a
about
misleading
what.
graph.
Okay, then this is something which is called misleading. Okay, it's clear.
Yes, sir. Yes, sir.
It's clear
Yes,
to
sir.
everyone.
Yes, sir. Move forward.
Okay, let's move for the next. You know mod and median.
Yes, sir.
Yes.
For categorical data,
Yes,
you
sir.
cannot use mean type of things. You can use only mod and median of the data. Okay, suppose I have data like this: A, B, B, C, B, D. Okay, then what will be the mod of this data?
Sir, B.
Why B?
Because
It
it is the
occurs
highest
frequency.
Yes,
number of
mod is
count.
something which occurs more frequently.
Frequency is more.
Okay, and median is always used for ordinal data. Just remember, because median is something when which you can find after ordering, after ranking the data.
Ascending order is required.
Yes. Suppose I have a t-shirt of sizes small, medium, large, small, again small, medium, large, and large. Okay. Then you have to order small, 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 medium, medium, large, large, large. Okay. Then suppose there is yeah. Suppose there is yeah. Then what will the medium? Median.
Medium one.
Sir, medium.
Median will be the something which is the middle observation. Okay. There is 1, 2, 3, 4, 5, 6, 7, 8 observation. Okay. These three can left out. So median can be this one or this one.
N by 2 plus N by 2.
No. See, average. You are calculating the
Average of two.
No.
Average.
See, this average can happen in numerical data. In categorical data, you can
can't
consider
happen in categorical data.
In categorical data, you can consider median this one or this one. Okay. Suppose I have only 7 observations, not this large. Then you have to left, this 3 observations and this 3 observations. Then your this medium size t-shirt will be the median.
Sir, if there are 8 observation and small size are 4 and medium size are 1,
then small can be median or
and
M can be median.
Both are median.
Both. At one time, small can be median or medium size.
Both can be median, so we can take any of them.
Any one of the. Okay.
Okay, sir.
And just remember, you cannot find the median for nominal data. But you can find the mod for the ordinal data as well. Here you can find the mod, and mod is small size.
Yes.
Right?
Yes.
Okay. Now I think this whole things are clear to everyone.
Yes, sir.
Okay.
Yes, sir.
Okay. So I think is there in hello?
Yes, sir. So for categorical, mode and median both. For ordinal also.
Yeah, for ordinal, see, this is the ordinal data. One second. Small, medium, large, and large. This is the ordinal data. You can calculate the mod of this data. What will be the mod here? S.
Yes.
And what will be the median?
M.
Yep. And suppose you have data like this: A, B, C, D. What will be the mod? A. And this is the nominal data. So what will be the median? Nothing.
There is no median.
Suppose this can be arranged. If this is can be arranged, then you can calculate the median. But if it's a nominal, then you cannot calculate the median for the nominal data. Okay.
Yeah, got it.
Yes.
Yes, sir.
Okay. Let's. I think is anything? Anyone else? Any doubt till this point?
No.
Okay. I think all the topic of week 2 is covered, right? Yeah, there is one thing left. You didn't see. There can be bi-model or multi-model. You guys also forgot about this topic. See, suppose this one, okay, M, large and large. So what will be the mod here?
Small size and medium size, both
Because
are the mod.
here this is the bi-model. Bi-model means two mods are there. If multi-model means something, suppose this is large
More than two.
and extra large and extra large. So here this is the called the multi-model.
Sir, what is model score?
Sorry?
What is model score? I think it is from
No, it's not in your course, right?
I don't know. Means I have seen one question which asked for model score. I think in week.
I think model scores. That means I think if then there will be a question like scores. Then you have asked about the what is the model score. Model is, and for mod you have to consider something which occurs more frequently, more number of the times.
Yes.
So means model score means mode, right?
See, model, what is model score? Suppose I have scores. For example, I scores 22, 33, 22, 30, 25, and again 22. And
it is a mode
these
of
are
scores that you take, na?
okay. This is the scores. So then, tell me model score. It depends on the data, and you have to find the mod. Mod is something which occur more number of times.
Mode of scores data set.
Okay.
So in this case,
clear?
sir, it will be unimodal,
Yes, sir.
right?
Yeah. If there are there is two mods, then that data will be bi-model. More than two mods, the data will be multi-modal. If there is only one mod, the data will be unimodal. It's clear?
Yes, sir.
Till this points is okay for everyone.
So we should move to week 3.
Yeah, we will move for the week 3 now. Okay.
Summarizing numerical data.
Yeah. In week 3, we are considering the numerical data. Means what operations you can
Excuse me,
perform
sir?
on numeric. Yeah, please.
Sir, what about the outliners? Like you will come.
Yeah. I will come.
Okay, sir.
That topic will cover in this one. Okay. No worry about that. I will cover all the topics. It can take 10 to 15, sometime more, but I will cover it.
Yeah, sir.
Yeah. So week 3 is about what type of things you can perform on the numerical data. And in week 3, suppose I am saying this one, A comma B. What is this? This is something class interval.
Yes, sir.
And class interval always represent as the this comma this. Okay. And what is this?
Lower limit.
Yeah, lower limit. Lower limit. And what is this?
Upper limit.
Upper limit of the
upper limit. And suppose I'm saying, tell me the class.
It is the same class.
Yeah, this is the same class. Suppose I'm asking about tell me the lower limit of this class. You will say A, and tell me the upper limit of the class. You will say B.
That is the lower value and the upper value.
Yeah. And suppose you have class interval A comma B comma C comma D, and okay. And I'm not doing this things. Okay. You can easily do it. Okay. I'm just considering this. Okay. So if suppose I'm saying, tell me the class width. What will be the class width?
B minus C.
No. Try to think 1 second.
A2
C.
C minus A.
A.
Class width is something.
Upper
Suppose you
limit
have,
of the
yeah. See,
previous
suppose
class
class
minus
width
lower limit.
something, yeah. See, suppose this is something. Okay, your class interval like this. So suppose I'm saying class width. So your class width will be lower limit of the next class minus lower limit of this class, previous class. That means this 20 minus 10 equal to 10.
Sir, there cannot be a gap between B and C, right? B and C have to be the same value.
Sorry?
There cannot be a gap between B and C, right? B and C has to be the same value. One is open interval, one is closed interval. In A, B, C, D.
It can. Yeah, it can. So you understood the class width, right?
Yes, sir.
Okay. So just tell me about the class mark. What is class mark? Class mark is something average of the class interval.
Upper plus lower limit divided by 2.
Okay. Till this point, it's clear to everyone, right?
Yes, sir.
Okay. Now we can move ahead.
Sir, we can say class mark is the middle of the
Yes,
class.
yes. Class mark is something. Suppose I'm saying you have 10, 20. Okay. So what will be the class mark of this data? Miss 50.
Yes, sir.
Miss 10 plus 20 divided by 2.
Yes, sir.
Okay. And you know what is stem and leaf plot?
Yes, sir.
Okay.
Yes, sir.
Stem and leaf plot is something. Suppose this is stem and this is leaf. And see, one remember thing, there will be key will be provided like that. Yeah, 7/0 means 70. Okay. Suppose 75 can be represented as suppose, and stem and leaf plot is something which is already in ascending order. Means this next observation will be 67, 76, 77, and 78. Okay. And again, it will be 81, not less than 78.
Excuse me, sir.
Yeah.
Sir, can you please explain this by taking continuous data set?
If continuous data set is something, key will be provided. Suppose I'm saying I like suppose what will be key will suppose I think consider like that. Yeah, this means 7.1. Okay, but it will be it can it will be it will
वहां गए राय क्या रखता है बकर बकर मत कर
Mute, sir.
yeah I am too. So stem and leaf plot is already in ascending order. Suppose I'm saying 77. 77 is what? This 7 and this 7. Okay.
Yes, sir.
And suppose yeah, I'm saying tell me, and see, remember one thing. This is what is meaning of this one? 81. And one thing always remember, it can 1 again, but it cannot be 0.
Okay, sir.
Because it's stem and leaf plots. In stem and leaf plots, things are already
In
in
ascending order.
Okay, it can be 1, 81 and 81, not 0. Okay.
Sir, I have a question. Means there was one question in which we were given the stem and leaf plot, and it was said how to take the stem such that there are these n number of occurrences of stems only.
It was 9 observation. I also have a doubt in that question. They were saying
okay, we will check. It's in practice, right? Yeah. So feedback is there, right?
No, sir. Actually, it was not there in that.
Okay. We'll do in the ending of the session because we have to.
Yes, sir. I'll prefer mailing you that.
Okay.
Right.
Okay. That will mess.
Right.
Now, stem and leaf plots will be clear. Okay. See,
yes, sir.
In a stem and leaf plot, suppose I'm saying, tell me
sir,
the.
I have a doubt in this. Mostly in this stem and leaf type questions, what are the what questions are asked? Like,
see, suppose I'm saying, see, stem and leaf plot. Suppose suppose I'm asking, what is the median of the data?
Right, sir.
So here you don't, there is no need to arranging the data. Here data is already arranged. You have to just count. Yeah, there is 1 2 3 4 5 6 7 observation, then these 3 left and these 3 left, so median will be 78.
Okay. So like sometimes you don't have to write 77 comma 78. No, right?
No, you can directly
No, sir, because your observation has an odd number. If it is an even number, I'm saying.
Then
if it's an even number. So for example, suppose
decimal value.
for example,
it
this
will
is
be
74,
average.
this is 75. Listen to me,
Yes,
one
sir.
please.
Right, sir.
Okay, then there are total 8 observation.
Right,
Then
sir.
left with the initial 3, means
Yes,
this 4 5 and 6 and this last 3, then you have 77 and 78. So just take the mean of these two.
Right, sir.
Okay, sir.
Here no need of arranging the data.
Okay, sir. So it is would be 77 7 plus 78 by 2, right?
By
Like that.
2.
Yes.
Okay.
Okay.
Okay. Okay, sir.
Okay, now yeah. And see, you have, suppose you have data like any data like x1 x2 x3 x4. Okay, you can calculate the mean of this.
Yes, we can calculate it.
Okay, by 4 you can calculate the median of this data.
Yes.
Means middle observation if odd, and average means average of
Middle average observations average
will be mean of the n by 2 and
n by 2
n by
plus
2 plus 1th observation. Okay, if even, and mod you can easily do by counting.
Sir, it's
Okay?
n by 2 and n by 2 plus 1. Na?
Yes,
so
yes,
means 8 by 2,
suppose you
4
see,
and 4. 4
suppose
and
you have
4
4
and 5
observation. Listen to me. You have 4 observation. That
Yes,
means
sir.
4 by 2 and 4 by 2 plus 1 means second and third.
Anyone we can take.
No. Mean of these two.
Okay.
It's a numerical data.
सर फिर से रिवर्ट करो नहीं समझ आया.
See, listen to me. Suppose you have data, I'm taking the data. Okay, 3 5 3 4 5 6 7 8 and 9. Okay, these are the 7 observations. Okay, I'm saying median of the data. So median, what will be there? If it's odd, so you can directly n plus 1 by 2th observation, which is nothing but middle observation. Means there is total 3 3 6 7 observation. That means 7 plus 2, that is 8 by 2 means 4th observation.
Yes.
What is 4th observation? This 6.
6th.
Yes, sir.
So median is your 6th. When it's in odd. Okay. And suppose I took the even number of observation. 6 7 8 9 10 11. Okay, 4 6, yeah, here n is 8 means your number of observations is 8. Then
average of 4th and 5th observation.
Yep, Purnendu.
So please ask them to unmute the mic. Now it's very confusing because you are not audible.
Now
Yes,
am I audible?
sir.
See, here your median is even number of observations. Okay, so what will be the median? Sometimes you can median, see, when your number of observation is even, then your median will be average of n by 2th and n by 2 plus 1th observation. That means you have 8 observation in total. That means 4th and this 4 plus 1, yani 5th observation.
Yes, sir.
Okay, average of. So what is 4th and 5th observation? 4th is this, 5th is this, and you can left you will left this 3 and this 3. So directly 7 plus 8 by 2, that means 7.5.
7.5.
It's clear?
Yes, sir.
Oh, nice.
Yes, sir.
Yeah, it's clear, sir.
Okay, fine. So you have suppose x1, x2, and x3, x4 observations. Okay, and suppose I add a constants to all the observations. Okay, suppose x1 plus c, x2 plus c, x3 plus c, and x4 plus c. Okay, then what will be the new mean?
Old mean plus constant.
Old mean plus
Constant.
should I derive it?
No, sir.
No, sir.
No, sir.
No, sir, it's very clear.
It's clear.
Fine.
And
Yes, sir.
suppose I multiply by the each observation by a constant, then what will be the new mean? X
Old
bar
mean times
into c.
constant.
It's clear to everyone?
Yes, sir.
Yes, sir.
Fine. When you need to derivation type of or any confusion, then you can ask me. You know what is median? Okay. Suppose I add a constants to all of the observation, then what will be the new median? So your new median will be old median plus that constant. And similarly, if you multiplied by constant, then your new median will be old median
times
Into C.
It's clear to everyone?
Yes, sir.
Okay. For example,
Sir, tell it with respect to outliers also, means which
I
will be
will.
affected by outliers.
Okay. See, similarly, same pattern will be for mod.
Mode also.
Okay. Now I will go for the outliers. See, suppose you have data 10, 12, 8, and this will be 20, 30, and suppose again 10. Okay. So what will be the average of this data? 10 plus 12 plus
8 plus 10.
It will be 20, 30, 40. It will be 10.
10.
Okay. And what will be the median? Suppose this is again 10. Okay, this 10. So your mean will be 10, right?
10. Yes, sir.
What will be the median of this data? You have to arrange 8, 10, 10, 10, and 12. So median is 10. This is 10 observation. Okay. And what is the mod of this data? 10.
10.
Okay, nice. Suppose there is an outliers. For example, suppose this is instead of 10, this is 120.
Then median will mean will be affected.
So your mean will be affected because your mean will be 10 plus. Just add this and tell me what is this.
Yes, yes.
Average will be
30. It will be 30 plus 128. Okay. Means 30 plus 128 divided by 5. It's coming out to be 31.6. If you see, mean is affected by the outliers, but your median is, if it's 120, is 10, mod is 10.
Yes, sir.
Okay, means you can say median is least affected. Sometimes it can happen, it can affect it. Okay.
Yes, sir.
Yes, sir.
Yes,
It's
sir.
clear. It's clear to
Yes,
how
sir.
it's affected by outliers or not.
Yeah, clear, sir.
Yes, sir.
Sir, it is
Mode
saying
is also
mod
not
is
affected. No?
set.
Sorry.
Mode is also not affected.
No. Mod is not affected.
Sir,
Here
median
median can be affected because see, suppose instead of 120, your 100 is there. Okay. Suppose in data is like that 8. Instead of 20, 100 is there, and then 10, and then 10, and then 10. Okay. No, it's let me go with this example. It can
median is the middle value. So how
sir, you can take example.
No. It can affect it because see, it can least of its median is least affected. It can
Okay. So
okay,
it may
because
be
10, 10, 1 second. Suppose there is 101 and 120 and kind of okay. Suppose your yeah, suppose this is your data. Okay.
Okay.
And initially it was like 10, 10, 101 and 12. Okay, for example, then it will be 10, 10, 12, 101.
Okay.
Then your median will be average of these two. Suppose this 12 will become 1200. Then it will be 10, 10, 100 and 1200.
Yes,
then
it will be
median can be
affected,
median will be least affected, not already, but mean will affected by the outliers.
Sir, it is said that mode is sensitive to the outliers in the data.
Yeah,
Mode
you
is
can say.
sometimes it is also affected.
Sometimes it can happen.
So median stays the same, mode changes sometimes, right?
Yeah. And now we will move for the measure of dispersion is range. You know, range is maximum minus minimum.
minimum value.
So it's also affected by the outliers.
Sir, what will be the range for a continuous data? Will it be for the class of the same class or different class?
Sorry.
What will be the range for the continuous data? It is maximum minus minimum.
Yeah.
But in continuous data,
It depends on the data actually. What is your upper limit of this one? Okay. Suppose range is something maximum minus minimum. Suppose your maximum is 101 and minimum is this one. Okay. So range will be suppose this is
101 minus
so
10.
Your range will be 90. And suppose outliers is there, so your range will be 1990. So range is affected by the outliers.
Okay, sir.
Okay, it's clear. Now we will move for the variance. See, variance is something which are we are interested. We are interested in
How
knowing
varied
about
our data is.
yeah.
Interested to know that.
Our data is vary from the mean point. Means xi, your data is vary from the middle observation, means mean point of the data. Okay. And you have to consider all the observations. If it's divided by the whole observation, then it's called the population variance. Okay. Suppose I'm taking as small n, and if it's 1 by n minus 1 and summation I equal to 1 to n, it's see all the observations will be added, but division will be if n minus 1, then it will be the sample variance. Okay.
Okay, sir.
And why next things is coming standard deviation.
Sir, variance is affected by the outliers.
Yes,
because mean
affected by outliers.
But
standard
and what is the effect of so what is the effect of adding constants to the variance?
Yeah, I will come to this point. See,
standard deviation
tell me why standard deviation came into effect.
Values on the same scale.
Yes, that is the nice. Because if you know, suppose your invariance, your xi is data of height. Okay. Then this will be height square. Okay. But to get the to get the final result in the same units, we took the square root of these things. Okay. Then square root of height is height square, I mean centimeter square, will give the centimeter. Okay. That's why there is coming the same as for a sample standard deviation. Okay. Which is the square root of 1 upon n minus 1 summation xi minus x bar.
Sir, what is the relation between sample standard deviation and population standard deviation?
And it will be 1 upon n summation xi minus x bar square. Okay. And you have suppose observation, then if
Excuse
I
me, sir?
add the please go ahead.
Excuse me, sir.
Please go ahead.
So, what is the relation of sample standard deviation and population standard deviation?
You can interpret from this formula.
Is equal to 1 by n times the population standard deviation. I think that is the relation.
Okay. See, You know this one? If I add the constant all the observations, your variance will not be changed.
Variance will not change.
Should I derive?
No, sir.
Yes, sir.
No,
Yes,
sir.
sir. Yes, sir.
I know.
One second.
No,
One
no.
second. See. If you add this one second. I do it very fast. Okay. Suppose your variance is no. I add the constant to each observation. That means this one minus mean will be also changed. It will be 1 by n summation. This c
xi
will be
minus x
cancel
bar
out this.
whole square again.
This will be this thing. So your new variance will be the same as old variance.
Old variance.
So when you add the constant, then variability of the data will not be changed. Okay.
Got it,
It's
sir.
clear to everyone?
Yes, sir.
And
Yes,
suppose
sir.
Yes, sir.
suppose I multiplied with the constants, then
It
your
will be change the variance.
new variance will be old variance
Variance
into
times the
constant square. How? See, suppose this is xi into c, this is x bar into c. Okay, here c will be common. 1 upon n. Then c is under the square. Then your c square will be common. C square will be common. Then it will be summation xi minus x bar square. So it will be c square, your old variance. It's clear to everyone? I'm asking
Yes, sir.
everyone.
Yes, sir.
Yes, sir.
Till this points, any doubt?
No, sir.
No, sir.
Yes, sir.
No, sir.
Okay. And similarly for the standard deviation, adding the constant will not affect the standard deviation. Okay, means your c is added, then your
changes
new
in
standard deviation will be old standard deviation. Okay, if multiplied by this any constant, then your new standard deviation will be c times of
the old
standard
standard deviation.
Because why c? Invariance.
Because under root is come.
Yes. Invariance. It was c square into
Please
old
be
variance.
loud. So you're not audible. Please be loud.
It's for everyone.
No, sir, you are audible.
Yes, sir, you are audible.
See.
Crystal clear auditor.
Okay. See, new variance is c square times old variance. Suppose I took the square root of both sides, then it will be c into square root of old variance. It will be new standard deviation equal to c times of old standard deviation. Okay, till this point, it's okay to everyone?
Yes, sir.
Yes, sir.
And one important formula you can remember. See, you know what is sigma square means? Population variance. And you know sample variance.
1 by n minus 1 summation xi minus x bar whole square.
Okay, can I do like this? N times of sigma square equal to summation xi minus x bar square.
Yes, sir.
Is everyone getting my point? This point?
Yes, sir.
Yes, sir.
Okay, multiplied by this and multiplied this one. See, this quantity is same. Then I can write n sigma square equal to n minus 1 times of s, this one.
Yes, sir.
Then I can write sigma square will be n minus 1 divided by n into s square.
Yes, sir.
So you can remember these two quantity when your population variance is given, sample variance is given, and you have asked about the number of observations, then you can directly calculate from this formula.
Got it.
Got it?
Got your point, sir. Yes, sir.
Got it.
Suppose I gave you population variance something 10 point something, sample variance something 8 point something, and I ask about it, tell me the number of observation, then you can directly calculate from this.
That is square, population square by sample square.
Okay?
Okay, sir.
1
Yes,
minute.
sir, there was one question. Same.
Qualifier, attempt 1.
No, I think sir got disconnected.
Yeah, hello.
Yes.
Yes,
Hello.
sir.
Yeah. Till this point is clear to everyone. Okay.
Yes, sir.
Okay. Now, yeah. Now we will move for the percentile. Okay. Suppose percentile is something. Suppose I have data like this. Okay. So I'm saying 50 percentile. So 50 percentile means 50% of the data will lie below of this, and another 50% of the data will lie above this point. Is it okay?
Okay, sir.
Yes, sir.
Yes, sir.
Means suppose
Yes,
I'm
sir.
saying 100p percentile. That means your 100p percentage of the data will lie below this point, and suppose 100p percentile is here, and 101 minus p percentage of the data will lie this here. Okay. Suppose I'm saying 30 percentile. Okay. And 30th percentile is there, something here. Okay. That means 30% of the data. Just listen carefully. 30% of the data will lie below here, and remaining 101 minus p. 101 minus p means 70% of data will lie.
Okay.
It's clear?
Yes, sir.
Okay.
Sir.
And now what is the formula? Okay. So tell me how we can compute percentile.
And into P.
Okay. See, first we have to arrange the data. Okay. Then we have to find the n into p. After that, we have to consider two things. If np is not an integer, okay, then we have to consider the next smallest highest integer. Okay. If sorry, if np is an integer, then we have to take the average of np and np plus
less 1.
mean of this two observations.
Yes, divide by 2.
Okay. It's clear to everyone?
Yes,
suppose
sir.
I have data like 10,
Yes, sir.
20, 25, 30 and 45. Okay. And I'm saying calculate the
9 percentile.
50th 9 percentile.
Yes.
Okay, so just go with the 9 percentile. So your n is 5, p is 9 by 100, that means 0.09. Okay, so your np will be what? 5 into 0.09. What will be this one?
0.45.
0.45. See, these things is in decimal point.
Yes, sir.
Yes, sir.
So next smallest integer will be first.
1.
Means 10 will be
10 is the
9 percentile of your data. It's clear?
Yes, sir.
And suppose I'm saying no 10 percentile. For example, I'm saying 20th percentile. Okay. So your NP will be 5 into 0.20. That means 1. Okay. 1 is there in integer. So you have to take the mean of the first and second observation. Means 10 plus 20 divided by 2.
Okay.
Yes, sir.
So your 15 will be the 20th percentile of data.
Okay.
Suppose I'm saying 50 percentile of data, which is nothing but the
median.
Okay. 50 percentile will be 5 into 0.5.
0.5.
That will be 2.5. That
Yeah.
means third observation. So third observation of your data is 25, which is the median. It's clear to everyone till this point. Is it okay?
Yes, sir.
Yes,
Okay.
yes, sir. Yes, sir.
Now any doubt?
No, sir. No, sir.
Okay, fine.
No, sir.
We will move for the quartiles.
Sir, is percentile
Okay.
affected by
See,
outliers?
Sorry.
Percentiles affected by outliers? Are percentiles
Yes.
affected?
Yeah, it can affect.
Yes.
It depends on the data. Okay?
Yes, sir.
See,
Sir, please
quartiles
make
is
it
something which
faster. Our CD
divides
class is
your.
also going to start now.
Yeah. No worry about that. See, I will cover up till week 4. Okay, and you can watch on YouTube also. Okay.
Sir, I have also to go to the CT session. So please write my 3 questions theory questions.
What is your?
Sir,
theory?
graded assignment 3, question number 3, 4, and 8.
G3, 4 and 8. Okay.
Third question also, sir.
3, 4 and 8.
Yes, sir.
Okay. Just remind me, anyone. Okay. Yeah. See, yeah, quartiles is something which divides your data in 4 equal parts. Okay.
Yeah.
Means suppose here is Q1, here is Q2, and here is Q3. Okay. So quartiles, these 3 are called quartiles. Means this is called the first quartile. This thing is called the second quartile. And this
third quartile.
Called the third quartile. Okay. And see, all things are divided into the 4 equal parts. Means these things are 100. This means 25% is this, 25% this, 25% will be this, 25% will be this.
25, 50, 75, 100.
And suppose I'm saying only Q1. I'm asking about the first quartile. Okay. So first quartile is nothing but 25th percentile of the data. That means 25% observation will lie below this one, and 75% of the observation lie here.
Above that.
It's clear?
Yes, sir.
Are everyone getting this point? What is
Yes,
first quartile? First quartile is nothing but 25th
25%
percentile
of
of the data. Okay. And suppose I'm saying second quartile.
50%
what will be
of
this one? 50th percentile of the
data.
And third quartile, 75th percentile of the
data.
It's clear to everyone?
Yes, sir.
See, if you have remembered the definition of the percentile, it's asking about the 100p and 101 minus p. Means 100p percentile of the data means this below this point your 100p observation will be there, and remaining 101 minus p percentile will be there. That means suppose I'm asking about the Q3, so 75th percentile of the data will be lie below, means up to this point, and remaining 25% will be lie above this point. Concept of quartiles is clear to everyone, or any doubts?
Sir, interquartile range, sir.
Thank you.
Okay, 1 second. I will go. I will come that point. I'm asking till this point. Any one of you have any doubt?
No, sir.
No, sir.
No, sir.
The point
Is
by
it?
serial also.
Yeah. Point by serial is in week 4. See, I will continue because syllabus is big also. So you can watch on YouTube this or CT. Okay.
Can you take one more class?
Actually, this is not possible. See, on 30th you have exam, and you have to do a lot of things also.
Excuse me, sir.
Yeah.
Yeah, actually, I just want to ask that we were not informed of any mock test or anything like that.
No, there is no mock test for this one. You are just for re-attempting qualifier. This revision session is there.
So what will you?
Yeah.
Excuse me, I'm asking. Something.
Sir, can I attempt only one subject in this qualifier?
Actually, this type of limit for first attempt.
Try to support, na.
Is handled by the support team. Okay, you can ask.
Okay,
you can.
Yeah, sir. I just want to ask that what will you suggest to? I mean, just for a practice purpose of full course.
Just do practice assignment and graded assignment. That's it. It will be more than
Any
enough
timed
to
thing that we can practice, because my first attempt was I failed in my first attempt in only mathematics just because of time. I didn't able to manage my time.
Me
actually
also,
it's
sir.
Me also, sir.
depends on it depends on
And that
individual.
was only 10%. In all the
Okay.
subjects I scored 66, 79, 80%, but in mathematics I was left behind 10% only.
Actually it depends on the individual how you can manage the things. Okay,
So can I
so
give
just
earlier for my?
So we have to write our doubts in the
Yeah.
forum, or are you providing us a mail ID?
So you can pin your
For-
email ID, please.
see you have to any doubts, so you can post on the discussion forum or Discord.
Okay, sir. Okay, sir.
Okay. Let's finish this topic. 5-number summary. Suppose you have a data set and you find the minimum of the data set, Q1 of the data set, Q2 of the data set, Q3 of the data set, and maximum of the data set. Then it whole things will called the 5-number summary. Okay. So how you will find the Q1? Suppose, sorry, earlier you had data 10, 20, 25, 30, and 45. Okay, 10, 25, 30, 35, and 40. And suppose I'm saying you have to calculate the first quartile Q1. Then how you will calculate this? Your N is 5.
N is 5. So
What is P?
P is 0.25.
Yeah, P will be
0.25. Yes, sir.
Then you can calculate the NP, and if it's in decimal, then take the next highest integer, and if it's an integer, then you have to took the mean of the NP and NP plus 1 alphabets. Okay.
Sir, data should be arranged in ascending order, no, for this.
Yeah, data is already in ascending order. When you have to calculate percentile, quartile, Q1, Q2, Q3, median, you have to first arrange the data in ascending order. Just remember the things.
Okay, sir.
Okay. Suppose I'm saying calculate the Q2, then your N is 5 and P will be 0.50. And Q3 N is 5, P will be
0.75.
And what will be the minimum of this data? 10, and
First
maximum of the
value.
data is
Last value.
It's clear to everyone?
Yes, sir.
Okay. And what is IQR? Interquartile range is nothing but can be calculated by
Q3 minus Q1.
Okay. So suppose Q3 will be what? It will be any one of you can calculate 0.75 into 5.
It is 7.5.
It will be 3.75.
3.75.
Okay. That fourth observation.
Yes, 35.
That means 35. So your Q3 is 35. What will be the Q1?
Minus 25.
So
Sir, it
Q1
will be
is
25.
1.25 and
30.
25.
No. Q1 will not be 30.
Sir, it will be
25.
25.
25. No. Q1. What is Q1?
1.2.
Q1 is 25 percentile, so 25
Yeah.
into 5.
Q1, see. Q1 will be N into P means 0.25 into 5. It will be 1.25. That means the second observation. That means
25.
25.
So your IQR is 10.
10.
Yes, sir.
It's okay to everyone?
Sir, but what IQR signifies here?
IQR is signifies, suppose
It is used to find the outlier.
suppose you know what is outlier.
Yes, I know.
This is the maximum.
Hmm.
This is the minimum.
Okay, sir.
This is the Q1. This is the Q3. This is the
Yes.
IQR.
Okay. So it is basically relevant for
box plot.
analytic chart.
Okay.
Yeah, box plot.
And your Q2 can be
Median is the
here
middle
or
value.
here. See, Q2 can be vary means here according your data. Okay. till this point, it's okay to everyone?
Yes, sir.
Yes.
Okay. Now we will move forward how to calculate outliers from the data. Okay. Outliers is something which can be calculated. Outliers, suppose you calculate observation like this. Okay. Outlier something which is less than Q1
Excuse me,
minus.
sir.
Yeah, please.
So the whole video would be available in YouTube, right?
Yeah, it's
So we
live
can
on
leave,
YouTube.
right?
Yeah, if you have to attend, then you can leave. And
Okay, sir. Thank
who
you.
wants to attend this session, they can attend, and either you can watch the CT on YouTube or this things on YouTube also. It
Okay, sir.
depends on you. Okay.
Okay, sir. Thank you, sir.
And yeah, and outlier is something Q3 plus 1.5 times of IQR. Okay.
Good evening.
Good evening.
Thank you, sir.
Yeah. So anyone see, you can attend this session also. Okay. And you can watch the CT or on YouTube and these things also. Yeah, you know these things. If suppose your data was 10, 25, 30, 35 and 40. Okay. And to
Okay.
calculate outliers, you have to calculate the Q1 minus 1.5 times of IQR. Okay.
Yes,
And
sir.
suppose I calculated the Q1 minus 1.5 times of IQR, and your Q1 was 25 minus 1.5 times of IQR was 10.
IQR.
Okay. So what will be this? This is the it will be 10.
25 minus 50.
It whole things will be 10.
Yes, sir.
Okay. Then any observation are there which are less than this 10? Suppose this is 11, for example. Okay. Then outlier is something which should be less than these things.
Yes, sir.
Okay. This 10 is not, see, there is no any observation which are less than 10.
Less than 10.
Yeah.
Okay. First criteria is satisfied. And again, you have to find the Q3 plus 1.5 times of IQR. So your Q3 was 35 plus 1.5 times 10, and it will be 50.
Yeah. Yes.
So is there any observation which are greater than 50?
No.
No, sir.
No, sir.
No.
No, sir.
This criteria is not fulfilled, and this criteria, that means there is no outlier
Outliers in
for
the data
this
set.
particular data.
Okay.
Okay.
Yeah.
Suppose, for example, here 9, just assume. Okay. And you see, yeah, your this quantity is 10 and 9 is less than 10. So 9 will be the outlier.
Outlier.
This is just a assumption I'm giving to you example, because if you calculate the outliers for data, then things will be different. Okay. Now this concept is clear.
Yes, sir.
Yes, sir.
Is there any doubt regarding up to this whole week 3 syllabus?
No, sir. No, sir.
No, all good.
Sir,
All good? Yeah, please go ahead.
I have a doubt on
Yeah, please.
the qualifier 1, the question number 26.
Okay, what was the question actually?
If the sum of 7 observation is 28
Okay.
and sum of their squares is 140,
Okay.
then calculate the population standard deviation.
Population standard deviation, right?
Yes, sir.
Yes, sir.
Okay, see, it's given that sum of the 7 observation means 28 and sum of their squares, this one
140.
140. Okay, you know formula of population variance, or initially I will compute the population variance. It will be 1/7 summation xi minus x bar square. Okay.
Yes, sir.
Now,
Yes, sir.
just expand this one. Xi square plus x bar square minus 2 times of xi into x bar.
Oh, okay.
Okay. See why I did did this one? Because I have just these two quantity. I have to consider only summation xi and summation xi square. Okay.
Yeah.
And how I will get the summation xi square? Only when I will expand this one.
Yes, yes.
Okay. Till this point is okay.
Yes.
Okay. So your summation will go in the inside the bracket. It will be summation xi square plus summation of x bar square minus 2x bar into summation of xi, because this summation will go for the I things. Okay, for this xi, because what is x bar? X bar is something which is constant.
Okay, sir.
Is it okay?
Okay, sir.
Are you getting this point?
Yes, sir.
Okay, fine.
I got it.
Yes, yes.
Just tell me, it was 1/7 summation xi square plus summation x bar square minus 2 times of x bar into summation xi. Okay, can you tell me x bar is something 1/7 summation of xi? You can write.
Yes, sir.
Yes.
For example, 1 by n, let it be 1 by. So can I write n times x bar equal to summation of xi if your I goes to n?
Yes, sir.
Okay. So here n is 7 observations. So can I write 7 times of x bar equal to summation I equal to 7 up to xi?
Yes.
So this quantity can be replaced by this one.
Yes.
7x bar.
Yeah.
And initially it is given. It's given in the question. It's given. Yeah, it's given is 28.
28.
Okay. So 1/7, it's 140, and it will be what will be the value of this one? Anyone? Sorry. See, summation xi is given 28.
That's a 60.
No. What is this? Summation xi is given 28.
Yeah.
So what will be the 1/7?
1/7 is equal to 28.
28/7 equal to 4. This will
Sigma
be x
xi.
bar.
Yes, sir.
It's clear. Is it clear? This point is clear to everyone?
Yes, sir. Yes, sir. Yes, sir.
Okay. So it will be 2 into 4 into 28. And what will be this quantity? 7 into 4 square. This point is clear. This, see, what is meaning of summation xi square? See, what is meaning of this one? This means you are adding the x bar up to 7 times. X bar square plus x bar square plus x bar square and so on plus x bar square.
Okay.
That means 7 times x bar square, and your x bar is 4. That means 7 into 4 square. It's clear. So it will be 16 into 7, right? It will be 112, and it will be 8 into 28. That means 224. So it will be 140 plus minus. Yeah, it will be 28/7. That is 4. It's clear.
Sir, they say that answer is 2.
Yeah. Answer is 2. Here I have calculated population variance. Okay. So your population standard deviation will be square root of this.
Okay, sir.
That is a good question.
Now it's clear to everyone. And see, just remember these things. Okay, this expansion thing is very, very important. This I am doing again. Just try to understand. It will be 1/n summation xi minus x bar square. It will be 1/n summation xi square plus x bar square minus 2 times of x bar into xi, right? It will be 1/n summation xi square plus summation x bar square minus 2 times of x bar into summation of xi. Okay, it will be 1/n summation xi square plus summation x bar square minus 2 times of x bar into n x bar. See, x bar will be can be written as this one. So you can write it n times of x bar equal to summation xi. So this summation xi can be written as this n x bar.
Yes.
Okay. This expansion is very important, which will help you, solve a lot of questions. So it will be, you can write it this as any times of x bar square, because you are adding the x bar square till n times. Okay. And what is this? This is 2nx bar square.
Yes, sir.
Okay. So
Yes,
direct formula will be summation xi square. This is 2, this is 1, it will be nx bar.
That's very scary.
Okay. That means your sigma square is 1 by n summation xi square minus nx bar. In the previous one question, you can directly calculate here 1 by 7. It was summation. This quantity was 128 minus 7 into
Summation xi is sum of all the data points, and
yes,
x square is.
Sorry.
This nx square is means xi
this
understand.
nx bar square. This nx bar square.
Yeah, this nx bar square.
Okay.
So data is
here
given. It is given means what will be written in
Yes,
this
yes.
nx bar.
Yeah. 128. Yeah. Then I think this was there is some mistake. See, summation x square was.
I think there was a 140 somewhere.
140. Yeah, the sum was 140, right?
Yeah, 140 plus something.
40. Yeah. There, this was 140. Okay. Yeah, that's why it will come 28 by 7.
28 by 7. 4.
Okay. So you can, this is the this formula will come by the after expansion of the this one. You can remember or write it down also. Okay. Suppose your x bar is given and sum of squares is given, and you have to calculate the sigma square. You can directly calculate by this one.
But if n is given, then only.
Yeah, n is given. N will be given.
Okay.
Till now, everything is clear.
Yes, sir.
Yes, sir.
Up to this week 3, do you have any doubt?
No, sir. I have a doubt in week 4, sir.
Okay.
I also have a doubt in week 4. Sir.
Okay, so we can move for the week 4, right? Hello.
Yes, sir.
Yes, sir.
So if any one of you have any doubt regarding the concept of week 1, 2, and 3, so you can ask. After that, we will move for the week 4 and.
Hello, sir. I am audible.
Yeah. Audible you are.
Yes, sir. Question number.
Yeah.
Sir, graded assignment 3, question number 4, sir.
Question number 4.
No, sir. Question number 3, sir. Question number 3.
Okay, 1 second. After that, we will move for the week 4 and we will see the concept of week 4 and doubts of week 4, and that's it. Is it okay, to everyone?
Okay, sir.
Yes, sir.
Yes, sir. I have a question in practice assignment 4.2. Simpson's paradox.
No. Okay. This third one.
3, sir. Question number 3, sir. Question number 3.
Okay. What is your doubt?
Sir, what is the sample variance of the original?
I'm going with the general formula. Okay.
Yes, sir.
Okay. See, suppose just tell me the question. Mean and sample standard deviation of a data set consisting 6 observations is 12 and 8 respectively. Okay. And later it is noted that 19 is wrongly put it
No,
as
tell us
14.
14.
Okay.
What is the
Then
sample variance
what
of
is the
original data?
sample?
Sample for original data set. Yes, sir.
Okay. So I'm going with the general value. Suppose we have n observations in total. Will it be okay to you? Right?
Yes, sir.
Then you can put any numbers. Okay.
Yes,
And
sir.
initially, suppose your original mean was m and original standard deviation was s.
Yes,
Right?
sir. Yes, sir.
And later it is noted that your observation x is wrongly noted as let it be p. Okay, means
Okay.
your observation x is wrongly noted
Sir, we
as
can
p
also
and your
abbreviate it as NX.
so if you see what will be the mean, x bar is
X1 plus X2 plus X.
yeah, sum of observation. No, not take as x bar because x will confuse. Suppose
Yeah.
I'm writing as mean till sum of observation. I'm taking as s by
Total number of observation.
By N.
Total number of observation.
Yes, sir.
Summation summation I.
This is a m is given.
Yes, sir. Yes, sir.
It's okay. That
Yes, sir.
means your s will be n into m.
And yes, sir.
What is s? Means sum of the observations.
Yes, sir.
And suppose
Okay, so
you
from here we
in the
get
question,
sum of observations.
yeah, in the question it's given that your x is wrongly noted as p. Means your wrong observation is p. That
Yes,
means
sir.
your new summation will be what?
Old
This
sum is equal to
old minus the value.
minus this wrong observation plus new observation.
Yes, sir.
Yeah, we
It's
will
clear?
subtract the old observation and add the new one.
And add the new observation. Means
Okay,
corrected
sir.
observation. Okay. Then what will be the new mean? I'm interpreted as m dash. It will be s dash by capital N.
And
Till this point, it's clear.
yes, sir.
Yes, sir. Yes, sir.
Okay. Now we will move for the your sample variance.
Yes, sir. Yes, sir.
Okay. Okay. Let's move. Your s square is 1 by n minus 1 summation xi minus x bar square.
Yes, sir.
Yes, sir.
Okay. What will be this? You have to just expand. So after expansion, I will get this quantity summation xi square minus n times of x bar square. Is it okay?
Okay. The
Yes,
new
sir.
formula that you said you used
This
that one.
This one. Yeah,
got
this
it.
one. Okay. Here expansion is whole things, but this n is replaced by n minus 1.
N minus
Okay,
1.
sir. Okay, sir.
Is it okay?
Yes,
Yes,
sir.
sir.
Okay. Now you get this one, but you don't know what is the this new this what will be the sum of xi square for new data set. Okay. So
yes.
What will be the this let's do it corrected one. So what will be the corrected one? Means let it be denoted as b. So it will be as previous summation xi square means minus your wrong observation plus your correct observation.
Okay, sir. Okay, sir. Yes.
It's clear? See,
Yes, sir.
initially
Yes, sir.
when it was only summation of the observation, then you subtract the
We
that
have just
observation and
squared.
add the
Just
corrected observation. And here squares is there, means squares of observations. So you have to subtract the square of wrong observation and add the square of the correct observation.
Correct observations.
Okay, sir. Okay, sir.
Okay. Now I think
Okay.
you will be able to solve this further. Okay.
Yes. Yes, sir.
Okay. Anyone else? Any doubt up to week 3 or week 3 concept or questions? Anything? Hello.
No, sir.
No, sir.
Okay, so I think we can move for the week 4, right?
Yes, sir.
Please.
Okay. let me create a new Jambo. That will be easy.
हेलो सर।
Yeah, please go ahead.
सर week 4 में ना बहुत प्रॉब्लम है मेरा, तो
Yeah.
आप मतलब हर टॉपिक को थोड़ा डिटेल में एक्सप्लेन कीजिए।
Yeah. Okay. No worry. I will do it. See, you know, see, suppose you have data like this. Let me 1 second. Let me take a data of which I discussed by the man. Okay. One second. Where is data? Okay, see, data is like that. Okay, 10, 34, 14, 42. Okay, see, now we will see how two categorical variables are associated. Okay?
Yes, sir.
Yes, sir.
See, two categorical variables are associated. Suppose you have one categorical variable of gender means female and male, and another categorical variable is owning a phone or not owning a smartphone.
Smartphone.
Okay, so ownership, non-ownership is one categorical variable, and gender is another categorical variable. So we are interested to know whether it is associated with each other or not.
Yes, sir.
Okay, suppose there are 10 female who owns a phone and 14 female who do not own a phone.
Yes, sir.
And there are 14 male who owns a phone and 42 female who
do not own.
Okay, till this point is okay. See, these things are observed by the category. Suppose there are female who own a phone like that. Okay, and this is something which you have counted.
Yes.
Okay, till this point it's okay to everyone.
Yes, sir.
See, to find the association between these two categorical variables, we find the relative frequency. Okay.
Yes,
and see, what is meaning of association of two variables? Anyone can tell me?
Yes, sir. If the row relative frequency and column relative frequency are same, so these are
no. I'm see. I'm
association means basically how they are related.
Yes, how they are related. I'm asking about that. Means, see, I'm saying we are interested in knowing that if the information about one variable provides the information about the another variable.
If we do something to one variable,
then,
will the second variable change or
and
not?
if then variables will be associated. If the variables are associated, then the information of about the one variable will provide the information for the another variable as well.
Yes, sir.
It's okay to everyone?
Yes,
sir.
Yeah, okay, fine. Then see, for knowing the association, we have two methods. Owning or non-owning smartphone. Let me female as here and male. Okay. What is two methods? There are row relative frequencies and column relative frequencies. If row relative frequencies are different for some rows or column relative frequencies are different for some columns, then variables will be associated.
Yes, sir.
Otherwise, it will not be. If row relative frequencies are same or column relative frequency are same, then your variables will not be associated.
Not association with each other.
Okay.
Okay.
Yes, sir.
Suppose this. this one. Okay. Then just tell me how you will calculate the row relative frequency. Okay.
Yes.
Total sum of all rows
Total sum.
observation by
Now total and here total. Okay. So this total will be
24.
24.
24.
Okay. And this total will be 56. Suppose this
56.
is the okay. And this total will be 24. This will be the 56. So total sum will be 80.
80.
Right. This is
Yes, sir.
80 is called as a grand total. Means this
Yes.
total and this.
And this
Till
total.
this point is okay. Okay.
Yes,
So
sir.
suppose I calculate only with the row relative. Okay. Row relative means see this one. Your female is there.
Observation by
there.
total row.
Yeah. You know very well what is the relative, how you can calculate the row relative frequency.
Yes, sir.
Relative frequency, you can calculate the frequency divided by number of observations.
Yes, sir.
Okay. That is the relative frequency for the ith observation is any of the observations. And you have remembered sum of the all the relative frequencies is equal to 1. How? It will be f1 by n, it will be f2 by n, and so on fn by n. Okay. And this sum of the frequency will always the total number of observations. So it will be 1. It's clear?
Yes, sir.
Yes, sir.
Okay. Now your total is 24, here 56, and here is 80. So row relative frequency is this 24 divided by 80 into 100.
Sir, why 100? We are not calculating percentage.
Yeah, we are calculating percentage.
Okay, so we should always go for percentage and not just for values.
Yeah, this will be the 30%.
This is the mistake that I do most often. I just calculate it, but never go for percentage.
Yeah. And this will be the 70%.
Yes, sir.
This, see, how I calculate this. 24 divided by 80 into 100.
Into 100.
56 divided by 80 into 100. Again, see, row relative frequency means I consider this row.
Only rows total.
I will
observation by rows.
I will consider this row and I will consider this row. Okay.
Okay.
See, so for this, what will be this? 14 divided by 56. 14 divided by 56 into 100. What will be this quantity?
25%.
25.
Okay. And 42 divided by 56.
75.
75%, sir.
Now 10 by 24 is around 41.67%.
41.67.
And 14 of 24, it's around
58.33.
If you observe the rows, okay, then there is a significant difference, means they are not same. This, see, if you see this row and this row and this row, first and third row, there is a lot of difference. These percentage row relative frequencies are not same.
Yes, sir.
So that means there is
these are association with each other.
They are associated
between
with each other.
gender and owning
of a
and
smartphone.
not owning.
It's clear to
But
everyone.
sir, ma'am told it is not, means there is no relation for whether we have a gender or not.
No, it's data is little bit different, I think. If see there are 34. Okay, that's why it became different.
Okay.
Okay, see, in the ma'am, if you see a percentage are 22, 25, 24. So there are not a significant difference 22, 25 and 24.
Yes, sir.
Okay.
Yeah.
One second, let me connect my laptop with the charger. One second. Yeah. Yes. So till this point, it's okay to everyone. And
Hello, sir.
similar,
Yes, sir.
you can do for the call. Yeah, please go ahead.
Sir, can you please elaborate the association once again?
If you see, I say when row relative frequencies, okay, are different for some rows. If you see this row relative frequency 41.67, 58.33 is different from 30% and 70%. There is a significant difference, right? There is a lot of difference. If you see, compare with the 25, 30, 75, 30, there is a significant difference.
Yes, sir.
If
First
listen to
row
me.
is
Listen
more
yeah,
significant.
first row is more different with the second one and third one. If row relative frequencies are different for some rows, then your variables will be associated. It's okay?
Yes, sir.
Okay. Suppose I instead of 14, I took the suppose 34, for example. Suppose it's a 34. It will be 44. It will be 144. Okay. It's okay. So tell me, what will be the percentage of first row? It will be 22.72% something. That means 10 divided by 44. I am considering the first row. Row relative frequency means this divided by this total into 100. All of you have are aware about the how to calculate relative frequencies.
Yes, sir. Yes.
Means frequencies divided by total number of observations. Means this frequency divided by total number of observations is 10 by 44 into 100.
Yes, sir.
Okay. If you do 34 divided by 44, it will give you 77 point something.
Yes.
Okay. And if you do and this will give 25%, and this will give you 75%. Okay.
Okay.
And 44 by 100 will give you
Sir, you have changed the data.
Yeah, I have changed this data.
But we are calculating the same row relative frequency.
Yeah, we are calculating the same
44.
Sir, 44%.
No, it's a 24, right? It's a 24. Yeah. So it will be 24%. And it will be
then it is 56%.
It will be 76. Okay. Is it okay?
Yes, sir.
Yes, sir.
Okay. If you observe this data, 22, 25, 24, these are approximately same. See, if you observe first row, 22, 77, 10, 25, 75, 24, 76. So these are approximately same, not a significant difference.
Yes.
Yes, sir.
Then if row relative frequencies are same for some rows, then variables will not be associated.
They should be each other.
Okay.
Will not be associated with each other.
And in the second example, if you see this first row is a significant difference with this
third
row.
Third row, sir.
Then
yes, sir.
If there is significant difference, then association means variables are associated. Okay.
Yes, sir.
It's clear to everyone.
Yes, sir.
Yes, sir.
Yeah, fine. And see, you can do similarly for column relative frequency. Means how can you calculate column relative frequency? Means this 10 divided by 24. 34 divided by 76. Okay, you are considering the column. Okay, column observations, column total, column observations, column total.
Yes, sir.
This column observations, column total. Here I have considered only row. Means this row, this total. This row divided by 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 this total. association between two categorical variable is clear to everyone?
Yes, sir.
Okay.
Yes, sir.
I'm not getting the response with everyone. Is it clear to everyone?
Yes, sir.
Yes, sir. Got it.
Yes, sir. Yes, sir.
Okay. And you know bar chart, how can you draw? There is something segment bar chart. Segment bar chart means when we are divide the bar chart into segments. Means suppose here it was female category, okay, and suppose here was male category, okay. So suppose I'm interested in knowing so count. Means suppose 30. I think there was how many? Yeah, it was initially 14 for not owning a phone, 10 for owning a phone. Okay, so 14 was not owning a phone, 10 for owning a phone in female, and male 42 not phone, and let it be add, and 14 owning a phone. So this is you divided into the segments. Okay, this is something which which is called segment bar chart, and here you are considering the count. It's okay to everyone?
Yes, sir.
Yes, sir.
And you can also call this stacked bar chart also.
Stack.
Okay, means you can like choose the another color. Suppose green for non owning a phone, and red for owning a phone. Okay,
yes, sir.
now it's clear. Okay, and do you know about 100% stacked bar chart?
Yes, sir.
What is this? Can you tell me?
It will be according to the 100%, like
see, in this 100% stacked bar chart means we are not interested in a counts.
in not count.
We are interested.
Similar to
we are interested in only parts of whole.
Yeah.
Means suppose this is 0%, 10%, 20%, and up to 100%. Okay, and this is for female, and suppose this is for male. Okay, and if you see out of this 1.67% own the phone, 58.33% do not own the phone. Means this 100%, 41 point something own phone, and 58 point something do not own a phone. Okay, similarly in the male category, 75% do not own a phone and 25% own a phone. That means you can say suppose 75 is around here. Okay, it depends on still suppose 50% is there. It's on no, it will be accordingly your y-axis. So it will be 75% and 25% do not own. I mean own. It's clear. 100% here if you see, we are not interested in how many male are owning a phone or not owning a phone, how many male are owning a phone or not owning a phone. It's clear to everyone. Here we are interested in the proportions, percentage. It's clear?
Yes, sir.
Okay. Okay, let's move on. Now, next topic is scatter plot. Okay. See, scatter plot is something when two numerical variables. Now we have studied association between two categorical variables. Okay. Now we will study the association between two numerical variables. Okay. Means suppose both
contingency table.
It was contingency table.
This one was contingency table only.
Yeah.
Okay.
Yes.
Okay. No, actually means I have
scatter plot is something.
Yeah,
Okay,
actually
yeah,
means how
if
to
you have
solve the
queries, so you
questions.
can. What is question?
No, means there are questions in graded assignment, na? That I want to know how to solve because I get stuck sometime.
Okay, with regarding contingency table. Okay,
Yeah, sir.
let me go. One second.
Graded assignment. Last two
This question.
questions.
Last two questions you are asking about 6 and 7.
Yes, maybe.
See, if you are asking about the 6 and 7, so 6 and 7 is something 1 plus and BBK electronic. So 1 plus is also numerical variable and BBK electronics is also numerical variable. So you have to calculate the correlation coefficient between these two. I will come to that point.
No, not this one, sir. At the second question last.
Okay. Second, this one, right?
Yeah.
Yeah. So see, what is the last question? Okay. What is the question? What percentage of average students are in good economic conditions? Okay. Try to understand what percentage of average students are in good economic condition means good economic condition is given. Okay. That means this good economic condition is given to you.
And average is 95.
Average is it was asking about average student, right?
So average is 95 plus 96 divided by 54 plus 95 plus 86 plus 128 into 100. Is it like that?
See one second. It will what is the question? One second. Yeah. What percentage of average students
are in good economic conditions?
Means how much of the average students are in good economic condition means 95. You have to consider this total.
Yes, that's what I am saying.
95 divided by 95 plus 96.
95 divided by 95 plus 96. But good economic conditions are total 54, 95, 86 and 128.
No. You have, what is question? What percentage of average students are in good economic condition means average students are given. Okay. And out of those average students, how many percentage of students are in good economic conditions? So how many average students are there in total? 95 plus 96. And what will be the percentage for good being in good economic condition?
95 by 95 plus 96. Okay. Word confuses.
Yeah, word confuses. Suppose what proportion of total students are dull? So it's asking about the dull means 86 plus 70 means 86 70 divided by grand total. I mean grand total means this means addition of 8 observations.
Yes.
It's okay?
Yes, sir.
Okay. Now we can move further. Okay.
Yes.
So correlation.
Yeah. Now this is after scatter plot. I will see scatter plot is something which which you will give a quick idea about the relationship of the numerical variables. Suppose your x is another variable and y is the another numerical variable. Suppose this is the weight and the kind of height weight. Okay, for example, suppose your data is like this. Okay, you plot the scatter plot and you will get the pattern like this. This means there is association between x and y which is positive. Means this one means when your x is increases, your y
increases.
It's okay.
Yes, sir.
And suppose your data is something like that. Okay, you get the something, you plot the scatter plot and you get the data like this. Okay, then what will be the relationship? Negatively
linear related.
Why? Yeah, why negative? Because your x is increasing but
y
your
is
y is
decreasing.
Is it okay to everyone?
Yes, sir.
Okay. Now we will move for the covariance.
But what about curve and direction?
Yeah, curve
That
is
we have talked.
something. Okay,
Means
suppose you got
will we
this.
have any question related to
Yeah.
curve also?
No. You will get question only with the straight. I mean linear.
Sir, suppose if there are some data points which are in positive and some in means negative, like here, if you go down and plot some of the data, so we will just consider the general trend line. Na?
Can you repeat?
Suppose we are having some data where first it increases and then it decreases and then again increases. So what type of data means what type of relation can we consider?
Actually, depends. Suppose your data points are
Data
there.
is not
Okay.
tightly clustered,
So
let's say.
Okay, suppose your data is not tightly clustered and your data points are there. So here there is no any pattern.
No relation at all. No?
So you can say in general no relation.
No linear relation.
And for
no...
for computational purpose, you have formula of correlation coefficient.
Correlation, okay? Not covariance, because covariance
See,
is difficult.
Covariance is something which quantifies the strength of the linear
strength
association
of
between two numerical variables.
Two numerical variables.
Of linear association between two numerical variables. Okay. See.
Yes, sir.
And covariance you can calculate by the formula 1 upon n summation xi minus x bar into yi minus y bar.
Y bar.
These two variables and covariance can be calculated by this formula. And this covariance gives you the strength of the linear association between two numerical variables. It means one numerical variable is xi and second numerical variable is yi.
Yi. So we have to just take the deviation from the mean and multiply it.
Yes. See, this is a something. Suppose I'm saying this is the covariance between x and y. Okay, and suppose I'm saying covariance between x comma x. What will be this one? 1 upon n summation xi minus x bar into xi minus x bar.
X bar.
It will be 1 by n summation xi minus x bar square. Which is variance of x.
Okay. So here also we can use variance.
Yeah, variance is something you are considering for the one variable, and covariance something you are considering with the two variables. Is it okay to everyone?
Sir, there is a concept of like if one variable is positive related and another is negative, then covariance will be negative. Can you explain?
Yeah, I will come to that point.
Okay, sir.
It's till this point okay. It's this formula is called population covariance. This will be n minus 1, then it will call the sample covariance. Okay.
Yes, sir.
Yeah. See. Suppose if you see the covariance formula, suppose 1 by n summation xi minus x bar, okay, yi minus x bar. Suppose xi is your height data and y is data of weight. So this will give you final result in centimeter and kilogram.
Yes, sir.
Some unit.
Which is difficult to interpret.
Yeah. So that's why for unitless measure of association, we introduce the correlation. Okay, correlation is what? Correlation is nothing but covariance of x comma y divided by standard deviation of x into standard deviation of y, or you can say covariance of x comma y divided by square root of variance of x into square root of variance of y.
Sir, SD and X, so, SD of Y is population standard deviation or sample standard deviation?
Yeah, see, I will explain. See, if you use the population covariance, then you have to use the population here also.
Okay, sir.
Formula will be same. I will explain. See, let me go. What will be this? Centimeter into kilogram.
Yes.
Yeah.
And again, it will be centimeter into kilogram.
Centimeter into kilogram.
That will be cancel out. So you will
Yes, sir.
get the unitless measure.
Yes.
So unitless measure of association will be used, will be measured by the correlation coefficient. Okay. See, let me go with this one. Suppose I am using the formula of population covariance. Okay. Then you have to use the formula of standard, population standard deviation. That means 1 by n summation xi minus x bar square root of 1 by n summation yi minus y bar square. Okay. So this 1 by n, this 1 by n cancel out by this 1 by n. It's okay to everyone?
Yes, sir.
Hello. Because square root, see, you know, square root of 2 into square root 2 equal to 2.
Equal to 2.
Similarly, this is square root of 1 by n, this is square root
1 by 1
n.
can be taken common.
Okay.
Yeah.
Then similarly, if I use the suppose, so this will give you formula of this one. Summation square root of summation xi minus x bar square and square root of summation yi minus y bar square. Okay.
Yes, sir.
And suppose instead of population covariance and population standard deviation, I am using the sample, then it will be 1 by n minus 1, it will be n minus 1, it will be n minus 1. Okay.
Yeah.
And the things will be again cancelled out. Again, you will get this formula. Okay.
Yes, sir.
Everyone is getting this one. I think you are not getting this point. Silence from your sides.
Yes, sir.
Yes,
Yeah,
sir.
is
The
it
dog is
okay to
barking,
everyone?
that's why I have to silent mute.
Yes, sir. The cancelling is basic maths.
So you can directly use the formula of this one R. And just remember, if you use the population covariance formula, then you have to use the population standard deviations also for X and Y. Just remember. If you use the population for this one and standard deviation, sample standard deviation for Y, then it will give a wrong calculation. Okay, just remember.
Okay.
And you know, limits of R is minus 1 to 1. Okay. And you know, there are, let me draw this one once again. Suppose your data is like that. Okay. Someone has asked about the product of suppose this is your X and this is your Y, and your X bar is there, and suppose
And
your
Y
Y
bar
bar
is
is
there.
there. Okay. Then you I can plot this one.
Yes, sir.
Okay. So just tell me what will be this region. Means here xi minus x bar will be greater than 0.
Greater than 0.
And yi minus y bar will be greater than 0. Because here increases both things. Okay. This is your y bar, and upper is, points are upper on this y axis, and this is your x bar, and this is the right side on this axis. Okay. And so tell me what will be this region. Xi minus x bar will be what?
Y greater than 0.
Xi minus x bar will be what? Less than 0 or greater than 0?
Less than.
It will be less than
Less
0.
than, sir.
Yi minus y bar will be greater than 0.
Greater than 0.
And for this region, xi minus x bar will be less than 0, and yi minus y bar will also be less than 0.
Less than 0.
And for this region, xi minus x bar will be greater than 0, yi minus y bar will be
less than 0.
And product of these two will be negative, product of these two will be negative. You know, product of positive and
Into negative is
product of
negative.
negative will give the negative. Okay, so product of these two will give positive, and product will be again here positive. So it's clear.
Sir, there is a question in
Yes.
assignment 4.1 where it says that value of R can be from 0 to 1, means not -1, is means minus 1 to +1, means R lies between minus -1 to +1 is not given there.
Then that option is incorrect.
Okay,
I think.
so means we can take that
See, region of minus, what is this? Okay.
Yeah, I know that
Limit of R
lies
can
between that.
yes, R can be like in see, suppose I'm saying your one variable is increasing and another variable is decreasing. Then what will be the correlation coefficient?
It will be
negative or positive? Can you tell me how?
Because one is positive and one is negative.
Suppose see your x1 is here and x2 is here. Okay, and this is increases, and suppose your y1 is here and y2 is here. This variable is decreasing.
Yes.
Increasing means y1 should be here and y2 should be here.
Sir, y1 should be below now.
That's why I'm taking the example of your x is increasing and y is decreasing. What will be the correlation coefficient? Okay, your x is increasing here, y is decreasing here. Okay, then what will be the correlation coefficient? So can you this one? And this one?
Yes, sir.
And if you see by this,
sir, you are not audible.
Hello, sir.
Now, yeah, am I audible?
Yeah, sir. Now,
yes,
sir. Now this point is clear.
Yes, sir.
See, your this x1 and x2 is increasing, y1 and y2 is decreasing. Then this is the correlation coefficient type.
So it is means it is negative. It is negative.
Yeah. Yes, it is negative.
Okay.
Suppose your x1 is here, x2 is here, y1 is here, y2 is here. So this will be this will be this, then it will be.
Okay, so we can use this this type of mapping also to calculate.
Yes.
Okay, sir, got it.
So doubt in a qualifier paper.
Okay. Let's move. Yeah, first let me finish. Mostly 2 or 3 topics is left. After that, we will discuss the questions. Okay. And you guys are aware about the means how you can interpret the at what means. Suppose your R is lies between minus 0. So
yes,
suppose
sir, strong correlation.
Yes. I'm saying suppose your R is lies between 0.75 and 1. Then what will be the interpretation about
strong relation, positive.
And suppose I'm saying minus 0.25 till 2 plus 0.25.
It's not related at all.
And suppose I'm saying minus 0.75 to minus 0.5.
It's medium related or less related. What you can say, positive,
medium and negative.
Medium, positive, linear related.
So I
this
think
is a strong relation.
A strong and positive linear relationship. Okay, let me write it because it will give you a lot of idea. If you have remembered the week 4 graded assignment, there is a question. You have to calculate R, and after that you have to decide whether what type of linear relationship is there. Okay.
Yes, calculating R is the main part of that question.
Yes.
It gives headache.
Yeah. Then now it will be moderate and positive.
Moderate and positive.
Positive linear relationship. If suppose there is again can be, yeah, this will be weak and positive.
Weak and positive.
Weak and positive linear relationship. Okay. Then next can be minus 0.25 up to 0.25. Then there is absence of linear
relationship. Relationship. Sir, 0.25 to 0.5 is 0.50, no?
No. 1 to 5 to 2. See, this is the upper limit. This is the lower limit for this one.
Okay, got it.
Okay.
0.5 to negative
It will be minus 0.5.
Negative 0.2.
Then will be weak and negative.
Weak and negative relationship.
Okay.
Linear.
And next quantity will be minus 0.75 to r less or equal to minus 0.5. Then it will be moderate and negative. Okay. And you can interpret for the last one minus 1 to this one minus 0.75. Then it will be strong and negative relationship. So suppose is there is any question in which you have asked about like what type of linear relationship is there, then you have to remember this range actually. Okay, so you can take a screenshot or write it down, whatever.
Done, sir.
Done.
Done, sir.
Okay, so till now I think everyone is means everyone's doubt is clear, or anyone else has any doubt?
No doubt, sir. Only in questions of qualifier paper.
Okay. Till this point, it's okay to everyone, right?
Yes, sir.
Okay, let's move for the I think last topic is there. Point by
serial correlation coefficient.
Yeah. See, before this one we have studied association between two
Numerical and
variable.
categorical numerical association.
Okay. Which we have done by the contingency table.
Relative frequency.
In which we applied the in which
row relative
we
and
have
column
applied the row relative frequency or column relative
frequency.
Okay. If all row relative frequencies are same for some rows, then there will be no association.
No association.
If row relative frequencies will be different for some rows, then there will be association between the two categorical variable. Similarly, you can do for the column relative frequency. And we have studied the association between two numerical variables by correlation coefficient.
And also covariance.
Yeah, also covariance. Correlation coefficient is something unitless measure.
Unitless measure, yeah.
Okay. Till this point, it's okay.
Yes,
we have
sir.
also studied the association between two categorical variable, yes, association between two numerical variable. Now we will study the association between one numerical variable and one categorical variable, which is done by the point by series. Okay.
Yes, sir. But sir, I have a question. Means how to calculate point by serial using
Yeah,
just.
now I will calculate it. No worry about that. Point by serial.
So in Excel also there is no function, I think.
Yeah. No, there is no function. Association.
But yes, we have to go through the pain of calculating all these things.
Yeah.
Point by serial means.
Okay. Suppose your one categorical you can take as suppose I'm taking as a gender. Okay. And another variable is suppose marks or age, for example, age. Okay. So I'm interested in knowing. So suppose gender is like that. Okay. Female, male, female. Okay. And male.
Okay.
3, 6, and again you can take as male. Okay. and age is like 30, 40, 42, then 40, then 28, then 32. You can take as 40 again, and take as 52. Okay. See, point by serial is something you can code. Okay, female and male. Okay.
Yes.
Okay. Suppose I'm coding a female as 0, or
And
suppose
male as 1.
so. See, for the best practice, you know the formula, divide by sx into square root of p naught into p. See, this quantity you can take as
it is a population.
yeah, this is the population. Yeah, one important thing. This by mistake ma'am has wrote small sx, but this is something we have to calculate the population standard deviation.
If
Just
we go
remember
for
this thing.
sample, then we have to apply the
Formula
sample
will be changed.
correction.
Formula will be changed.
Yeah, sample
Okay?
correction we have to apply.
See, you can calculate the absolute point by serial, or you can code a 0 as one, which is more in number. Suppose I'm coding as a female in 0, okay, and male as 1. It will be 0, 1, and 1. Okay. So you know, let me erase these things first. Yeah. See, what will be the p naught? Means n naught divided by n. Okay.
Yes, sir.
So how many n is there? 1, 2, 3, 4, 5, 6, 7. Okay. And n naught means female, count of female.
3,
that means
3 by 7.
3 by 7. Okay. P1 is something proportion for male. That means 4 by 7.
Yes, sir.
It's okay. Now, you know y bar naught means mean of the observations corresponding to y naught.
Why
means
not? It is 0.
Mean
The
of
first.
30.
Only the female.
Then
30 plus
28.
28 plus 30.
Then this 3 means 30 plus 28 plus 32 divided by 3. What will be this?
9, 10. 80 by 3.
It will be 30. Okay. Now calculate y bar 1. Means mean of this observation. Not, sometimes students make mistake like he calculate the mean of whole observation. No. Y bar 1 means mean of this.
42, 40, 40, 52.
Mean of this. And how many observation is this? 1, 2, 3, 4. So it will be 42 plus 40 plus 40 plus 52 divided by 4 or 7?
4.
4. Because we are calculating mean.
43.5.
It's a 43.5. Okay.
Yes.
You have found this one. You have found this one. Now you have to find the population standard deviation. That means square root of 1 by n. Okay. That means how many observations there in total? 1, 2, 3, 4, 5, 6, and 7. Then it will be 1 by 7. Summation I is equal to 1 to 7 xi minus x bar whole square. That means you have to calculate the standard population standard deviation of this whole
entire.
This is the difference. You have to calculate the mean of corresponding the 0 and 1. You have to calculate the population standard deviation of the entire entire numerical variable, because standard deviation is something which can be calculated only for a numerical variable, right?
Yes, sir.
Yeah. Can you tell me, can you calculate the standard deviation for this gender, female, male, female?
Yes, sir.
You can you
we know the y naught and y bar. So
no, because this is a categorical variable. You can calculate the standard deviation or a mean type of things only for this numerical variable, right? And let me calculate. Just tell me observation 30, 42, 40. 1 second.
So 37.7 mean.
Mean or standard deviation?
Sir, mean 37.7.
Why mean? Why?
No, sir, I'm calculating.
Okay. Mean you are okay. Okay, you can calculate. See, let me do direct. I am doing directly on the Excel. Okay, 30, 42, and what is the observation?
40,
40, 28, 32.
28,
40, 28,
Yeah.
32,
Okay.
40,
40,
Yeah.
52.
52, right? Yeah. See, you can calculate the average. Okay.
Yes, sir.
This one. Then you have to do the formula like you know this xi minus x bar
Yeah.
square.
Hmm.
Okay, and I'm fixing the this mean. Okay, otherwise it will this okay.
Take any value.
$sign.
Okay. Oh no, what is this? Where it was? Yeah. Then this is the summation x. Now I have to calculate the sum of this one.
Yes, sir.
Only then I will get the summation of this one. Okay. And what will be the population standard deviation? First calculate the variance.
This
divided by 3, 7. Okay. And is square root of
59.
These things will be the population standard deviation. That means 7.74.
7.74.
And or you can calculate like directly a formula by formula. It's given the same
Sir,
answer.
what is correct to 2 decimal places? There are many questions.
Okay. I will clear it. So your population standard deviation is 7.74. Okay. Now, just remember in the lecture video, ma'am has by mistake it's mentioned SX, but she has calculated a population standard deviation. Okay. You got this P0, you got this P1, you got this one and this one and this one. See, if you minus this quantity minus this quantity, okay, then you will get, see, what is the formula? Y bar naught minus Y bar 1 divided by sigma X into square root of P naught into P1. Okay.
Yes, sir.
Yes,
If
sir.
you minus this, though it will give the negative quantity.
Yes.
Okay. That's why we will take absolute things. Okay.
Okay, so we have to take the absolute value.
Yeah. See, but first thing is that you can take absolute things, or second thing is that from here, male is more in numbers. Okay. So you can code
just
male as
change
0.
the encoding.
Yeah. If you change the male as 0, then you will get automatically Y bar 0 as this and Y bar 1 as this.
Yeah, got it. Ma'am explained it. Ma'am explained it.
Yeah. Everyone is getting this point? Hello?
Yes, sir.
Yes, sir.
Okay. So just do this this 30 minus 43.5 divided by 7.74, and this quantity 3 by 7 into 4 by 7, you will get your means correct answer. Okay.
Sir, there is also some means plot is there to find the.
Yeah. It's you can do like suppose female is 0, male is 1. Okay. Then age was, suppose you plot this like that. Okay. And you plot like this. Okay. Then you can interpret, yeah, age is no, there is no much difference between age
Means
of
if they lie in the same intervals.
Yeah. Okay.
The same
And
range.
suppose you got this like this, male is 1. Okay. You got age of female is like, and age of male suppose like that. Okay. Then you can say distribution, in the distribution of data, age of male is more than the age of female, kind of. Okay.
But in which type of question should I use this one? Means in calculation.
See. No. It's in calculation you have to do the calculation. After that you will get the point by serial. It's, see, plot is something is for general idea, quick idea.
Okay, so we can't use it actually in
No,
examination.
you can use for getting a quick idea. Yeah, how it can. Yeah, suppose you don't have time to solve any question. You can plot it. Yeah, you can get idea. If there is a option, then you can guess something. You can say, but
So means
this is
how
not a
can we
best.
interpret if this is a strong or a weak? Means it should
See,
be 0 and 1. So
yeah,
means
yeah. If
that
uh
interpretation
if it's
requires.
closer to 0, see, suppose you calculate a point by serial. If it's closer to 0, then okay, there will be no relationship. If it's closer to 1, then it will be the perfect relationship between a categorical variable and a numerical variable.
Okay. So in the first case, it is closer to 0, and for the second case, it is closer to 1.
For this one,
Yeah.
you can say according to data actually. Okay. So point by serial is clear to everyone.
Yes, sir.
And one more thing. Suppose this was the population standard deviation. Okay. Suppose I use the sample standard deviation. Formula will be changed because n sigma square will be n minus 1 s square. I have explained some time before. So sigma square you can write it as this one.
Yes, sir.
So your population standard deviation can be written as square root of this minus this into sx. Okay, so this your sigma x will be transferred by this quantity. If you want to use the population standard, sample standard
deviation.
Okay, otherwise you have to use the same directly use the population standard deviation because it will you will be
Sir,
solved it
in
easy.
examination, data set will be small, right?
Yeah, data set will be small and set will be like that. You can
In the last one,
yeah,
in the last
suppose
attempt one, there was one question of correlation, and it was 15, the same value and the negative of that value. So it was 0. We don't
See, in
even
the
need to
examination,
calculate that.
data is given to like that such that you can solve it easily. Suppose in data you get the mean of 10, then in EGV you can subtract from the mean and square it from like that. Okay.
Okay.
Yeah, and you have asked about the round off. Okay, correct to those two decimal. Suppose I get the 7.7456. Okay, so correct to two decimal place means I have to consider only two decimal place. So I consider 7.7. Before going to 4, just see the next integer. If it is greater or equal to 5, then this quantity will be increases by 1. It will be 7.75. And suppose I'm saying this is 7.7432 and correct to two decimal places, it will be 7.74 because after the two decimal places, it's not greater than
It is
5
similar to the seal or floor function.
Yeah, sorry. Now it's clear?
Yes, sir.
Okay.
Sir,
So
I am
think,
having doubt in one of the question of practice assignment.
I think
4.2.
see, topics are covered. More, all topics are covered. Okay.
Sir, if the correlation is near to 0, there is no association.
Yes.
And if it is near to -1, negatively associated.
In case of point by serial or
The point by serial, sir.
See,
point by serial can never be in negative.
No, that's why it can negative, but we are for best practice we are taking the absolute things. Okay, so that we can get positive things. Okay, if your value is coming out around to closer to 0, okay, you calculate the things and your value is closer to 0, close to 0, that means no relationship between categorical and numerical variable. Okay, if your value of point by serial is closer to 1, then you will say there is a perfect relationship.
Then it is closer.
Suppose your point by serial is coming out to be 0.08 something. Okay, so it's a closer to 0. Okay, then you can say there is a no relationship. And suppose your 0.5 series is coming out to be 0.97 something. Then it's closer to 1.
Yes, sir.
And you will say there is a perfect relationship. Okay.
Then it is closer to -1 negative association.
That's why I'm saying take the
Absolute
absolute
value.
value of.
Okay, sir.
Okay. Did you understand the meaning of absolute?
Without taking a negative value.
No. Absolute means absolute means it will convert the negative into the positive.
Yes, sir.
Or a best practice
Modular.
you can do for just do you can code the 0 which is more in numbers.
Okay, sir.
Okay, sir.
Okay. So for example, suppose I code the male as 0, for example, then your y bar 0 will be automatically greater than y bar 1. Then it will automatically give you a positive value.
Okay, sir.
Okay.
Okay, sir.
Okay, it's clear.
Yes,
I
sir.
think
It's clear.
topics of all topics of week up to week 4 is covered. Okay. So any one of you have any doubt regarding concepts or syllabus of up to till from week 1 to week 4, so you can ask.
Sir, I am having doubt and questions. Topics I understand, but in few questions I get lost. Means how to do that, how to extract those values.
Okay, I think there was some raised hand. Yeah, Purnendu Suglai, you are?
Yes, sir. Actually,
Yeah.
I have raised my hand. Actually,
Yeah.
there was a question from practice assignment 4.2. Simpson's paradox was given there. I don't understand the entire question even.
Okay, Simpson's paradox.
Just below it. This one.
Okay.
Means how the data is given, I don't understand.
Data is something, see. This
it is
is
merge
something.
of contingency table. Means
Yeah, it is a merge of contingency table. See, from this home up to home, there are own draw lost, and then there is away own draw lost, and home and away own draw lost.
But how to calculate anything?
See, okay. What is the question? Feedback is there?
Sir, actually, I don't understand the feedback because it is splitted into parts. Means it is not properly readable for me.
Okay, one second.
I have tried actually. I have tried all the practice assignment questions and I got stuck in this one only.
Okay, no worry. I will tell you.
The entire question. What does it mean by disaggregated performance and aggregated performance?
See.
Means what they are
Yeah,
trying.
this is the if you read the questions, Simpson's paradox is defined as the reversal of conclusion in disaggregated and aggregated cross tabulation. Okay. And this table is shows
what does reversal of conclusions mean, sir, here?
Okay, reversal of conclusion is how you are let me start with the question, and after that you will get the clarify. Okay.
Okay,
and
sir.
There is aggregate data. Aggregate data is something which is a combination of groups of data into single summary statistics. In the given cricket data, home and away data is aggregated data. That means this home and away is aggregated. Okay. Aggregated is merging of two things. Okay. And disaggregated data is the data that is divided into detailed subcategories. And in this whole data, your disaggregated data is home or away. Okay. Aggregated is home and away. Disaggregated is home or away. Okay.
Okay, sir.
So these things based on the given table in this one, which captain has the better record in ODI captaincy in terms of win percentage? So tell me, what was your approach?
My approach was like calculating all the win, that is won. Captain A won 9, captain won, or taking all the won from home away and home and away, and then and divided it by the total number of matches.
And you get the correct answer.
I don't know.
Okay, let me go with the feedback so that we can do it in a fast way. Okay, I will describe you. Okay, no worry about that. Just due to time.
Also means here means like how the feedback is given, they are creating tables, but I don't create tables. I just calculate it individually and then merge it.
In the question, it says we have to says the which captain has better record in the ODI captaincy in terms of vote. Okay, so if you see the only percentage of A, okay, what is A? A, how many A is 85?
85 he won in total. In total he won 85. Okay.
Okay. In total he won 85 plus 1 and plus 66. What
and
is
these are
plus
all
1?
the one. No.
Yes. No. Better record.
85, 1 and 66 is the total matches that they played.
Yes. Better records means you have to consider won, draw, and lost in both.
Okay.
Okay. So 85 plus 1 plus 66, that means 152. Okay. Your 152 is total, and this out of total, what is win percentage? 85 divided by 152. This
okay.
Okay.
Okay. So sir, means here can we separate out all the tables and then
you can for your simplification you can separate it.
The question only asks about the win percentage. It doesn't say whether away or home. So we have to consider the entire matches that he has played.
Okay.
Now, similarly, you will do for the B. That means what will be the B? 175 plus 0 plus 85 will be total, and win percentage will be 175 divided by total. Okay.
Into 100.
Okay, and you will get the answer. Okay. Similarly,
loss percentage I now understand.
Yeah,
Basically
loss
summation
percentage.
all the values
Similarly,
divided by the
loss percentages and best win percentages. Best win percentage is what?
Best win percentage means who won.
See,
most
you
of
have
the
home,
matches.
away, and one second. What was there? Yeah, home away, and home and away. Okay.
Okay.
If you see which captain has the best win percentages, so best if we in home ODI it was 10, and he won the matches in home 9.
Yes.
So percentage will be simple, 9 by 10 into 100.
Okay.
Similarly, for B you have to calculate in home, and in home you see B is 75%.
So basically we are considering only the home matches.
Home, because see, if you see the question is home ODI matches.
Okay.
Okay, you have to consider the best win percentage in home ODI matches. Okay. So just go to the table. If you see in this table, your home is this one, 901 150 050.
Yes,
so
sir.
for captain A, it will be 9 divided by 10. Why 10? He plays the total 10 matches. 9 plus 0 plus 1.
And he won only 9 matches.
9 matches. Similarly for captain B, 150
it will
divided
be
by
200.
Yeah.
200
And similarly
means 150 divided by 200.
200. Similarly, next question was for away. Similarly, you can proceed further. That's it.
Last one.
Last one.
This reversal of conclusion means.
No. See, no. Does the above data illustrate simple paradox? See, win percentage was for home 90%. Similarly, you can do away. Okay. Similarly for total. Okay.
Okay, sir.
You can do, right?
Yes, sir. I can do that.
Okay. Similarly for draw percentages. Similarly for the loss percentages. Okay.
Okay.
And
but sir, why are we calculating loss and draw percentage also?
That's what the Simpsons paradox actually. What is it's a question? If you see, from table 4.1, the winning percentage in ODI cricket is higher for A than the B. Okay, winning percentage are higher for A than B for home. Okay, if it's for a no, it's for home and away. Okay.
Okay.
But overall, it appears the winning percentage is higher for Captain B. Here, things are reversed.
Okay, so means individually it is
Individually, it
seeming
was,
like A is
yeah.
winning, but actually in aggregate, Captain B is winning.
Okay, that's why reversal of the conclusion means individually he got the win, and at the total, he conclusion is reversed.
Okay, sir.
Okay. Got
Yes,
it?
sir, got it. So basically, means what I can do is that I can just break down all the content, contingency table, and then I can calculate the total and then go for calculating it. That will be much easier.
Sorry, you're not audible to me actually.
So
Actually,
qualifier papered out.
Okay. Okay, next one is Tarun Pranav. Hello, are you there? No one. So
Sir,
Junok Jain.
Sir, excuse me, means I am leaving, but as I asked the question at the very beginning, will we have to get total for means each subject 40% and then best of two consider, or will we have to get only one subject best of 40% and it will be considered?
Actually, yeah,
Hmm?
and I'm not sure about this
Yeah,
one.
actually, I asked the team. They never
Yeah.
replied to me. I asked the team,
Okay,
but
you
they
can
never
you can
replied.
you can give you can do again. Well, they will reply. Actually, teams are busy, but you will
And also one
you
thing,
will.
sir, there is a call support, but it is always busy. So is there any way to
Just
contact?
okay, just put it on. You can put it on discussion forum. Okay, we'll forward further.
Okay,
Okay.
sir.
Okay. Next one is Junak Jan. Do you have any doubt?
Yes, sir.
Yeah. Please.
Sir,
What?
there is a question in practice assignment 3.1.
Practice assignment 3.1, right? 3.1.
Yes, sir.
Okay. One second. 3.1. Which question?
Sir, I think so. You can scroll down it.
Okay.
So okay, so the question, so the after refreshment, I have got a new question. The data set is 1, 6, 10, 14, 4, x1, x2. In this, and the mean is given as 7, and the standard deviation is given as under root 1 by 106 upon 6. We have to
One
find.
second. This one, right? This first one, right?
Yes, sir.
Okay. So how did you approach this one?
Sir, sir, in this I have a doubt. There is an answer. The given answer is 104 plus. In this step, so can you check answers once again?
Answer.
Yes, sir.
Okay. One second. Yeah, answer is
Yes, sir. Sir, so please.
2.
Yes, sir. Sir, मेरे को
Okay.
I have a doubt in middle. So can you scroll up? Yes, sir. So here the 104 plus x1 minus 7 whole plus I can't connect the step. How this
Okay,
one?
you are facing problem to solve this equation, right? So I do not need to solve the from beginning. Okay. Hello.
Yes, sir.
Yeah. Okay. So I have to solve from this one. Okay.
Yes, sir.
Okay. So just tell me the equation.
Sir.
100. Sorry.
104.
104 plus
No, sir, I can't understand how with this 104 has came here.
Okay, you are facing from this to this.
Yes, sir.
Okay. Okay, 1 second. Okay, let me do. Initial equation was summation. Yeah, this there was a lot of calculation actually. This was divided by 6. Okay. This whole things is given as 106 by 6. You got this point? Your standard deviation is given this one.
Yes, sir.
Okay. So if you squared on the both sides, then you will get summation xi minus 7 squared divided by 6 equal to 106 by 6.
Okay, sir.
Okay. Now, what was the observations? This equation will come on the solving this equation actually. Tell me the observations. 1, 6, 10, 14, 4, x1, x2. Okay.
Okay, sir.
What was it? 1, 6,
1, 6, 10,
10, 14,
4,
4, x1 and x2. Okay.
Yes,
What
sir.
is meaning of this one? That summation of xi minus 7 square divided by 6 equal to 106 divided by 6. Okay. So observations was your 1, that means 1 minus 7 square plus 6 minus 7 square plus 10 minus 7 square. Next observation was 14, right?
Yes, 14 minus 7 square. 4 minus
4 minus 7 square plus x1 minus 7 square plus x2 minus 7 square divided by 6 equal to 100 divided by 6. See, this 6 will be cancelled out with this 6. Okay.
Yes, sir.
So you will get only this quantity. So this, what will be this? This will be 36. 1 minus 7 is minus 6 and minus 6 square will be 36. Hello.
Yes, sir.
And what will the next term? It will be 1.
1.
Just tell me, what will the next term? 9 and 49 and 9 plus x1 minus 7 square plus x2 minus 7 square equal to 1 equal to 106.
Yes,
if
sir.
you add this one, 36 ones, this is 46 plus 58, 46 plus 58, yeah, this will give you 104.
Okay, sir.
Okay.
Okay, sir.
Now I think you can solve further, right?
Yes, sir.
It's clear?
Yes, sir. Clear.
Okay.
Thank you, sir.
Yeah, thank you. And next one is Josna Chaudhary.
So can we go through the Jan 30 paper revision?
One second. Sorry.
Jan 30 paper revision.
Jan what?
Attempt 1 paper revision.
Actually, there was a session you can rewatch. If you have any doubt, any particular question, so I can help out. But whole paper will take a lot of time actually.
Sir, you didn't take my name.
Okay.
Sir, I'm in the line.
Okay. Okay, yeah, please go ahead.
Sir, my question was from mock test 1, question 9.
Mock test 1.
Sir, qualifier paper.
Okay, one second. I will go. I will come to this. Question number 9, right?
Yes, sir. Sir, upward.
Yeah.
Yes, sir.
Yeah.
Yes, sir.
Yeah. What is up?
Sir, I calculated this, but my answer is 2.74, and the answer is not matching.
How did you calculate this one? Means just tell me, how did you calculate the mean?
Sir, sigma xi fi by fi minus 1.
Fi minus 1? I'm asking about the mean. See, your number of bikes only 0, 1, 2, 3, 4 and 5, 8, 4, 2, 1. Okay. So in the question, it's given the number of bikes means xi is given 0, 1, 2, 3, 4. Okay. And frequency is given 5, 8, 4, 2, 1. Okay. Means fi is given 5, 8, 4, 2, 1. Okay. So you know the formula for calculating the mean, summation fi xi divided by summation of fi.
Yes, sir.
Okay. So
it will be fi minus 1.
Fi xi. Why fi minus 1?
Sir, this answer has given the formula and it was written over there.
No, I'm doing just x bar. Okay. If you calculate the sample standard deviation, then it will be 1 by n minus 1 summation fi xi minus x bar square. This thing. Okay. Have you applied this formula or just summation xi minus x bar square?
Just a second, let me see.
Okay. See, then your frequency is given, then you have to multiply it by the frequency. Okay.
Okay, sir.
Okay. Now
yes,
I think you got where you made a mistake.
Yeah, sir. I will try it once more.
Okay. Okay. Someone has asked me about the qualifier.
Yes, sir. I.
Yeah, Gargi. What was the question? Can you tell?
So there is a strong positive correlation between the marks obtained by student of class 10th and class 12th statistics.
A strong correlation coefficient. Okay.
Strong positive correlation.
That means your R is between this one.
Yes, sir.
Yeah, please go ahead.
Obtained by the student of class 10th and class 12th in statistics. If the population standard deviation of the marks obtained by student of class 10th and 12th is 2 and 5.
2 and 5. Okay.
5.
Okay.
Yes. Then which of the following is or R could be possible value of the population covariance between the marks?
Okay. What is the options?
So 7, 8,
yeah,
9.5, 11.
11. Okay. See, you know what is R? Covariance divided by sigma x into sigma y.
Yes, sir.
Okay. And R is given strong and positive means it can be anything 0.7. So I'm going with the suppose 0.7, 0.75. Okay. I'm taking as 0.75. So it will be covariance divided by sigma x is 2 into 5. So your covariance will be this 0.75 into 10. That means 7.5.
Yes.
Your correct answer will be from no? Now you can think, and your maximum limit will be 1. If you take it as 1, suppose I'm taking R as 1, so it will be covariance will be 1 into 10. It will be 10. Okay. So this is this correct answer.
Sir, how? 8
because
and 9.5.
See, for strong and positive correlation, you have limit 0.75 to 1.
Yes.
If you put the 0.75, then you will get the covariance 7.5.
Correct.
Okay. So there is 7.5 is, and if you put the 1, you are getting covariance as 10. That means your covariance lies between this and this quantity. 8 and 9.5 is between this and this quantity, right?
Okay. I got it.
Oh, anyone else has any doubt? Anantha, Priya?
Yes, I have a doubt.
Yeah, please go ahead.
The marks out of 100 scored by Kabir in
Scored
class
by?
Kabir
Okay.
in class 10th exam is given as 58, 78, 75, 49.
Can you tell me whether it is question? Where it is? In any activity or?
No, sir. It's from Qualifier previous year question paper.
Okay. Qualifier. Okay. Let me create a new example.
So there is one more doubt in chat section.
Yeah, please.
Sir, in chat session, there is a question, two teachers A and B.
Okay, this one. Okay.
Two teachers A and B are assigned to check the mathematics paper attempted by the students of class 10.
Okay.
So the question is in chat session also. The mean and population variance of the marks of the 20 papers checked by the teacher A.
Yeah, this is something you have to try.
The first mean I've got it, but the second population variance answer is coming wrong.
Okay. You can try. You can try with all your best practices. Okay. That is the something which is in which you have to put more effort. Okay. That's why I'm not. Yeah.
So I tried it, but it is not coming. I am not sure how. So can you just help me to how to. So at least give me how to solve.
I will again say you have to try. Okay, you can try.
So if not coming, then can we put on discussion forum?
Okay, put it on.
So
just try.
is there,
okay, just try and
so what is the logic behind it? How to I'm just
see this is a question, something in which you have to think a little bit more. Okay, you have to.
So we have to calculate the A mean and the B mean, and have to add or.
Sir, I got the mean. Sir, I got the
yeah.
first question, but the problem is in second in a population variance. The answer is
okay,
not coming.
Just try it, and if you will not get, then we can discuss later.
So
okay?
when so
just
13 is the paper.
yeah 30th is paper, I know, but this type of questions you can say can come in your exam. So that's why you have to you have to think a little bit more. Okay, that's why I'm not discussing that. Okay,
so how to calculate the mean? How to calculate the mean?
You can. She has calculated mean, so you can discuss with her. Okay. Yes, sir. Someone has asked Kabir's question.
Yes, sir.
Yeah. Please go ahead.
I'm posting the question in chat box.
The point by serial will not be affected by outliers.
Okay, it can affect actually according to data.
Sir, the question is posted in chat box.
Okay, 1 second.
The mark out
Kabir
of
marks, okay. 10th exam, if Ramesh has scored 1 marks less than Kabir in this subject, then they calculate the correlation coefficient between the marks scored by Kabir and Ramesh. Okay. So just tell me 58, 79, 58, 79, 75, 49, 82, 65. Okay. What is the answer? Answer is 1?
1. Yes, sir.
Okay, I will tell. See, this is marks of Kabir, and you have asked about the marks of Ramesh has scored 1 marks less than the Kabir. Means 57, 78, 74. Yeah, 1 second. Okay. See, when suppose I am representing X as a marks of Kabir and Y as a marks of Ramesh. So what is your Y? Y is X minus 1. Sorry, one second. It's okay.
Yes, sir.
So your queries will be this one, and the standard deviation of X into standard deviation of X minus 1. Okay. Sorry, one second. Then can you tell me covariance of X comma X minus 1? You know, if you add or subtract any constant, so your this standard deviation will be equal to this minus this one by the property of adding constant in the standard deviation. Have you remembered? Hello. Hello.
Yes, sir, you are audible.
Yeah. Do you have you remembered this one? Suppose I'm saying your observation is something and I'm adding a constant to all the observation, then my new standard deviation will be equal to the old standard deviation.
Yes, sir.
There is no effect of adding constant or anything. Okay. So this two standard deviation will be equal. Standard deviation of X. Standard deviation of X. Till this point, it's okay.
Yes, sir. So
yeah. Yeah, Josna, please. See, let it be. Let it be. We will go of simple calculus. Okay. See, Kabir marks is 58, 79, 75, and 49, 82, and 65. Okay, just tell me the observation. Okay. 58. What was the observation next?
58, 79.
Yeah.
75.
Okay.
49.
Yes.
82.
Okay.
65.
65. And Ramesh marks is less than 1. Okay. That means 58 minus 1. Okay.
Yes, sir.
If you calculate the correlation between these two, this will give you 1. Okay.
Okay, sir.
And how 1? See, just remember one thing. Why I wanted, why I see. If there is a relation, no, variables are linearly related. Means see, your X is this and Y is this. Y is nothing but X minus 1. So your Y is linearly related to X. Okay. When your variables is linearly related, then your correlation coefficient will be 1. How? You can derive for the with the formula. See, covariance of X comma X minus 1. And you can do standard deviation of X into standard deviation of X minus 1. Okay. Hello. Hello. Am I audible?
yes, sir, you are audible.
Yeah. Yeah. See. And you know formula of Rxy. You know formula of Rxy is nothing but summation of xi minus x bar into yi minus y bar divided by square root of summation xi minus x bar square root of summation yi minus y bar square. You know this one?
Yes, sir.
Okay. Now it will be summation xi minus x bar. Instead of y, we have x minus 1. that means xi minus 1 minus x bar minus 1. You people will very well know, if we add the constant to each term, then our new mean is equal to old mean plus that constant or minus of that constant. Okay, so one will be subtracted here. It's clear?
Yes, sir.
Okay. And
okay,
what
sir.
will be the standard deviation? Square root of, suppose, yeah, oh no, what is the denominator? Summation xi minus x bar and summation yi minus y bar. Okay, so it will be square root of summation xi minus x bar square and square root of summation, instead of y we have xi minus 1 minus y bar, that means x bar minus 1 whole square. Okay.
Okay, sir.
Okay, what you will get here? Summation xi minus x bar, and this one will be cancelled out, this one. If you minus will go within the bracket, it will be minus and it will be plus, then it will be x I minus x bar divided by summation xi minus x bar square root of summation xi minus x bar square. It's okay.
Okay, sir.
And what is this quantity? Summation x into this quantity, this will give you a square.
Yes, sir.
Now it's clear? Hello?
Yes, sir.
Yeah, till this point it's clear?
Yes, sir.
So what if you see the numerator, this is under root and this is also in the square root. So this term will be summation xi minus x bar square divided by summation xi minus x bar square. It will be cancelled out and you will get the answer as
1.
So it's clear. Just remember, when its variables are linearly associated, your correlation will be 1. Suppose I'm saying Ramesh marks is more than 2 marks in each subject than Kabir, then also you will get the correlation coefficient again as 1.
Okay, sir.
Okay, it's clear?
Yes, sir. Thank you, sir.
Yeah. So anyone else has any doubt, or we can close this session? Tarun Pravan has raised hand. Do you have any doubt? I think he's not there.
Sir, I have doubt on graphical representation.
Okay. What is doubt?
One second, sir. Sir, for the count of schools in each grade category, for the given data, we can represent through bar chart and Pareto chart also, no, sir?
See, you can use Pareto chart, and Pareto chart you will use when you have sorted the frequency. Means you have put the frequency in ascending or descending order.
Okay, sir.
Okay, for any data. Suppose I have data 10, 15, or 12, and for example 20, and I have these 4 categories. Okay, and I simply draw the bar. Means here is category A, and here is 0, here is suppose here is 10, here is 15, and here is 20. Okay, so your A is 10, that means this. Your B is 15, that means this one, and your A C is 12, that means something around here, and your D is 20. So this is something bar chart. You are interested in count 10, 15, 12, and 20. It's okay?
Yes, sir. Okay.
Suppose why when you have to use Pareto chart, suppose I sorted this frequency in ascending order. Means suppose I did this one like 10, 15, 12, 20. Then I did like 10, 12, 15, and 20. This is in ascending order. So your initially bar chart is 0, 10, 15, 20. So your A is this, your B is this 15, your C is around 12, and your D is suppose 20. Okay. Pareto chart is something when your frequency is ordered, means A is 10. Okay. Then what is 12? 12 is C. Okay.
Okay.
And B is 15. That is here, and D is 20. Suppose 20 is here. So this is something. So this is your Pareto chart, and this is your bar chart. Okay, and you can draw this Pareto chart in descending order also. Means first D, B, C, and A. And one most important thing you can remember, see, if there is ordinal data, okay, suppose this is small size t-shirts and medium size t-shirt, this is large size t-shirt and Excel. So sorry, order must be preserved. Means first small bar, bar of small with there, and bar of medium size will be there, and bar of large size will be there, and bar of Excel size will be there. Okay.
Okay, sir.
Order is preserved means first small, then medium, then large, and then Excel.
Sir, for the count of schools in each grade category, which chart is better?
Actually, what is data? Count of school means data is like 10, 20. Is this okay?
They have given only the count of schools in each grade category.
In each grade category, yeah, bar.
For this, we won't use Pareto.
See, for if there is mentioned grade in something, order must be there.
Yes, sir.
So order must be preserved. Okay. Just remember the things. When order is not there, then you can use the Pareto chart.
Okay, sir.
Okay, and the bar with the highest bar is the mode of the data. Okay, and in the Pareto chart, if it's in ascending order, the last bar can be mode of the data. Okay.
Okay, sir.
Okay. Anyone else any doubt, or we can close?
Sir, jersey number of cricket players is numerical variable. Is it incorrect?
So tell me. Suppose Dhoni has jersey number 10. I don't know exact. Suppose Sachin has 7 and Virat Kohli has 10, 8. It's not a numerical, it's a categorical variable.
Oh, but how?
See, numerical variable is something in which you can perform the mathematical operation. Okay. So can you perform mathematical operation like 7 plus 8 equal to 15, and you will say jersey number of Sachin and Virat Kohli is more than the jersey number of Dhoni? Can you make any mathematical interpretation?
No, sir.
No. Can you say jersey number of Dhoni is much better than jersey number of Sachin? You can't.
No.
That's why it's a categorical variable. See, categorical variable is something where is qualitative type of things is inbuilt, and numerical variable is something where you can perform mathematical operations.
Okay.
Suppose instead of jersey number, I'm saying Dhoni average match scores is around 5,800, and Sachin is has match runs around 6,700. Virat Kohli has 5,900. Then you can perform mathematical operation. You can say Sachin score more runs than Dhoni and Virat Kohli. You can calculate the average marks of these three players. So here these are the numerical variables. It's clear?
Yes, sir, it's clear.
Okay, anyone else any doubt, or we can close?
Sir, there will be any quiz for the qualifier?
Sorry?
Sir, there will be any quiz? before the qualifier?
No, the first quiz you can practice mock one.
Sir, will you
Yeah.
please say the formula when the sample standard deviation and population standard deviation are given and we have to find the number of observations?
I think you have joined late or
I missed that part, sir.
okay, I will explain more. See, your population standard deviation is this. Sorry, population variance is this one.
Yes, sir.
Okay, this is something I equal to 1 to n. Okay, so can I write it as n times of sigma square equal to summation I to n xi minus x bar square?
Yes, sir.
This n will go to this side. Okay, it's
Yes,
clear.
sir.
And sample variance is something this. Okay, so can I write it n minus 1 times s square equal to summation of xi minus x bar square?
Yes, sir.
So this put it as equation 1 and this equation. So this quantity is equal to this quantity.
Yes, sir.
That means I can write n times of sigma square equal to n minus 1 times s square.
Yes, sir.
So can I write it as sigma square equal to n minus 1 divided by n into s square?
Yes, sir.
Now you can calculate. Suppose population variance is given, sample variance is given, and you ask about the number of observation, you can calculate from here.
Yes, sir.
Okay.
Thank you, sir. Thank
You
you, sir.
can take a screenshot or write it down the formula. It's clear to everyone?
Yes, sir.
Okay.
Yes, sir.
Anyone has any doubt, or we think we can close the session?
If the number of observations is given and population standard deviation also given, how to find the sample variance?
You can transform this formula. Okay, see, your what is formula? This is your formula. Just remember this quantity. Okay. And you are saying, your number of observation is given and sigma square is given. You have to calculate sample square. Okay. This is the population variance. So can I write it n by n minus 1 sigma square equal to s square?
Yes, sir.
Then you can calculate the sample variance. If you ask about the sample standard deviation, then just calculate this quantity and take the square root of this one. That's it, the formula.
Oh, okay, sir.
Just remember this one. Okay. This one, and I have did the expansion of the formula if you noticed the things. Okay. Summation xi square minus n times of x bar square. Okay. This is the expansion of this one. Okay.
Oh, okay, sir.
Okay. So I think, do you have any doubt? Anyone else? Anything else? Okay. So I think we can close this session.
Sir, about histogram.
Histogram is something you can draw for the continuous data.
Continuous.
One second. Let me see. You know how to draw bar chart?
Yes, sir.
This one, and suppose this one and this. Okay. Histogram is something you are given the class interval. Okay. Suppose 0, 10, 20, and 50, 30, and 40 is there. And suppose I'm getting 0 to 10. Okay. Then this is something. Then 10 to 20. Suppose 10 to 20 is something, this one. Okay. Because these are okay. And 20 to 30. So 20 to 30 is this quantity. Okay. So these are something which are attached with each other.
Yes.
Okay. This is this kind of something. Okay. This is called 40, 50. So suppose this is the histogram. Okay. And suppose I'm asking about tell me the class mark of this interval. So what will be the class mark? Can you tell me? Class mark of any interval is nothing but average of the lower limit and upper limit. Means 10 plus 20 by 2, that is 15.
15.
Okay, that is something which is class. And I'm asking about the class width. Means 10 minus 0, 20 minus 10, 30 minus 20, 40 minus 30.
10.
Okay, it's clear?
Yes, sir.
Okay. Now, anything else? Any concept or anything?
Sir, can you write which are sensitive to outliers and which are not?
Okay, see, I have explained. Do you, I think have you joined late, right?
No, sir. Means I need a range is sensitive.
No, ranges. There is not any ranges. Actually, it depends on the data. It's varies. It's totally depends on there. Suppose your data is like 10, 20, 15, and 15. Okay. So what will be the mean? Mean will be your 30 plus 70. Yeah, 70 by 4. Let it as 5. Okay. No, 50 plus, for example, 10. It will be 40, 60, 80 by 5. Okay. That means 60. If you calculate the average. Okay. If you calculate the median. So median will be what? Median will be, for median you have to arrange the data 10, 10, 15, 15, 20. So median will be this middle observation 15. And what will be the mod? Suppose this 10.
It's bimodal.
Bimodal. Let's make a uni model. Let it be, it's bimodal. Mod is 10, 15. Okay. Suppose instead of 20, you have 200.
Okay.
Okay. Then your mean will be changed.
Yes, sir.
Because it will be 30, 50. It will be 250 divided by 5, and you will get 50. Suddenly, your mean is affected by outliers. Means it will change from 60 to 50. Right?
Yes.
And if you see median is not.
A median is 15.
Mod is again 15, but it will depend on data. So median and mod is you can say least affected by the outliers.
Oh, mean is affected.
Mean is affected, and median and mod is least affected.
Okay, sir.
Okay. I think now it's clear to everyone.
Yes, sir.
Yeah. Okay. I think we can close session, right? Hello.
Sir, in the qualifier paper, question number 27.
What is the question?
Means wrong statements. Mode is sensitive to outliers. Median is not sensitive.
Just think about that. Okay. Just think. You can interpret. You can visualize from data. Okay. I have told in the last one how it's affected or least affected. Okay.
Yes, sir.
Yeah. Just try to think about that. Okay.
Okay, sir.
Okay. Okay. So I think we can close this session. So anyone else any doubt? Okay. So bye everyone.
Thank you, sir.
Yeah. Thank you for being here, and all the very best for your qualifier exam.
Okay, sir.
Okay. Thank you. Thank you, everyone.
Okay, sir. Thank you, sir.
Thank you.